MCC All India quota TN.
Hello, my cuties, my future doctors. How are you guys? Ellarume happy and safe irukringala? Can you please let me know in the chat box? Please, everybody. Yes, Hariharan, Shiva, Manoj. Yes, NEET aspirant Manasa. Hi, Hallie. Yes, da. Okay. Oh my God. Thank you so much for the chocolates, guys. Okay. So, right now, we are going for the current electricity chapter. We will cover the concepts. We will cover the questions. So, in the one shot la ungalku vandu you will get a confidence. Okay, you will feel like okay, current electricity vandu okay, right now vandu oru yeah, it is almost okay da apdi oru feel you will definitely get it. Okay, va ready ya? Ready na? Can you just put a red heart in the chat box, everybody? Konja red hearts. I'm starving for red hearts. Yes. So guys, those who have forgot to like the session, ippave like panikoda. So first of all, current electricity chapter சொல்லும்போது அதுக்கு முன்னாடி நீங்க வந்து if you have not shared this video with your friends na ippave share பண்ணிக்கோ. And also மறக்காம நம்ம channel subscribe பண்ணிக்கோ. ஏன்னா வந்து latest ஆன updates, notifications எல்லாமே வந்து we are just doing everything and you will get all the informations on time. So if you are feeling like yes, this channel is useful, quality content you are getting, then definitely you can just subscribe the channel and also share with your friends. ஏன்னா வந்து நிறைய students they were looking for good quality lectures ஆனா கிடைக்கல. So if you are just feeling confident, okay, அப்படின்னா மட்டும் உங்களுக்கு வந்து உங்க friends கிட்ட you can just share with. Okay, இதுல கூட voice is breaking ஆடா ஹலி, எனக்கு தெரியலடா என்ன ஆச்சுன்னு. Okay. Right now, okay, Vada? Right now, எப்படி இருக்கு? Is it okay now? Hope it is clear. Please let me know. Yes. So, அப்படின்னா first வந்து we can start with the term current. Okay. So, நீங்க தான் சொல்லணும் what is current. Okay. What you feel or what you know about current வந்து நீங்க தான் சொல்லணும். What is current? Current electricity chapter la first sentence itself current da. Yes, Akti. J.A. Christopher. Hi da. Yes, Amrita. Hi. Yes. So right now current na it is basically the rate of flow of charges with respect to time in any area of cross section. இதுதான் வந்து நம்ம current. So current சொல்லும்போது we will be definitely having the way we are talking about velocity, speed and all, we have instantaneous and average. அப்படின்னா நீங்க தான் சொல்லணும் what is the meaning of average current and instantaneous current, அதுல difference என்ன இருக்கு, what is exactly it is. So first of all I'm going to write the equation for the average current. Average current சொல்லும்போது delta Q divided by delta T. Now I'm going for instantaneous current. Instantaneous current is nothing but dq by dt. Clear, Arika? So right now we have two types of currents. One is nothing but average current and another one is nothing but the instantaneous current. Okay, so right now just observe. So average current வந்து நான் இல்லடா, I'm not the one who is making the question book. அதனால எனக்கு அது answer I can't answer that. Okay, so right now நான் வந்து என்ன சொல்லியிருக்கேன், average current and instantaneous current. Okay, so average current க்கு வந்து we can say that, let us say நம்ம we are just taking, basically speaking, இப்போ வந்து you are just taking the time interval வந்து if you are just taking too large, okay, then definitely we will talk about average. Okay ba, so right now maybe sometime the flow must be very flow must be very what is it, high, sometimes less ah irukkalam, ana vanda I'm just taking for a longer time interval. Now let us say எனக்கு வந்து இந்த ஒரு fraction of second இல்ல எவ்வளோ current, okay, எவ்வளோ current வந்து it is actually flow, or let's say எவ்வளோ amount of charges வந்து flow பண்ணிருக்கு, அந்த ஒரு instant ஓட, okay, அந்த ஒரு particular instant இல்ல what happen அது வந்து தெரியணும்னா you will be finding the instantaneous value. So basically very simple. Let us say if you are just finding, okay, if you are just finding for the instantaneous value, it is for a very short time period, and if you are finding it for the longer time interval, then we can say that this is going to be average. Clear arika? Everybody please let me know through your favorite heart, everybody. So this is what the basic idea. Now the thing is, like, let us say now I'm just going to draw charge versus time graph. Okay, charge versus time graph. And I got it like this. Appadina, my first question is, what is the slope of this graph? What is the slope of this graph? Can you please let me know? Ipo you have a QT graph. Okay, cute ana or graph irukku. So that is what we have, our QT graph. In the QT graph kadachena, adoda slope enna? Slope is nothing but whatever be the change which is happening along the y-axis, and whatever be the changes is happening in the x-axis. Inga vandu y ila change na adu vandu nama dq da, and nama x-axis ila change na adu vandu t da. So I'll be get it as dt dq by dt. That is what the current. Okay, dq by dt is nothing but current. So இப்போ வந்து இந்த क्वेश्चनல இந்த மாதிரி ஒரு கிராஃப்னா there is no confusion. ஏனா வந்து ஒவ்வொரு பாயிண்ட்லயுமே இதோட ஸ்லோப், இது வந்து ஒரு inclined straight line இல்ல. So if I'm taking any point in this graph, இந்த கிராஃப்ல ஏதாச்சும் ஒரு பாயிண்ட் if I take na, அதுல வந்து என்ன இருக்கும், இந்த ஸ்லோப் ஓட வேல்யூ வந்து சேமா இருக்கும், which means இந்த ஒரு क्वेश्चनல I don't have any trouble with, இப்போ நீங்க வந்து instantaneous கேட்டாலும் average கேட்டாலும் அதோட வேல்யூ வந்து சேம் தான். ஏனா வந்து இந்த கிராஃப்ல ஒவ்வொரு பாயிண்ட்லயுமே இருக்கிற ஸ்லோப் வந்து சேம் தான். ஆனா வந்து let us say இப்போ வந்து if you are getting a graph like this, okay, இப்போ வந்து என்னாச்சு, இங்க வந்து q தான், இங்க வந்து t தான், okay, y axis ல q தான், and நம்ம x axis ல வந்து t தான். அப்படினா நான் வந்து I'm just going to take very small interval. Okay, this is what the small interval. So இப்போ வந்து if I'm taking the small interval, அதுக்கு corresponding ஆன ஒரு small what is a change in the charge flow will also be there. Then I will take it. Okay, and this is what the instantaneous value. Now let us say now I'm going to take a longer interval, which means this is what our t1 and this is what our t2. So for this particular time period, there will be some change will happen over here, correct? Okay, so now the thing is like in the or t1 to t2 la nama charge oda flow வந்து different ஆன positions இல்ல different ஆன time இல்ல different ஆ இருக்கும். But when it comes to instantaneous, you're talking about for the particular time. So இப்போ வந்து இந்த பாக்கும்போது இந்த dt you can see the two lines separately, right? ஆனா வந்து actually இந்த dt na it is almost ஒரு close to zero value, ஆனா zero இல்ல, அந்த மாதிரி தான். So அதனால இந்த two lines, okay, இந்த two lines வந்து actually உங்களுக்கு வந்து you cannot even identify the separation between these two lines. Clear ஆ இருக்கா? Everybody understood? So basically we were just talking about average and the instantaneous current da. Average current na the charge flow for a very long interval da. When it comes to instantaneous, we are finding it for a very small time interval la, adukku corresponding ana what to say chargeல இருக்கிற separation இல்லனா chargeோட flow தான் அந்த small time intervalல corresponding ஆன charge flow தான் actually வந்து நம்ம instantaneous value. Clear ஆ இருக்குனா can you just respond with your favorite heart please everybody please respond. Everybody perfect. So அப்படினா நான் வந்து ஸ்டடி பண்ணிருக்கேன் I is equal to Q by T தான். So நம்ம electrostatics chapterல இந்த Q we have studied one current வந்து it's a scalar quantity. I'm coming to it. Okay, just hold on. Okay, so இப்போ வந்து என்ன ஆச்சு நம்ம electrostaticsல இந்த chargeக்கு quantization when we were studying about the quantization அந்த டைம்ல we have discussed about இன்னொரு equation for the charge. What was that? Do you remember? Charge க்கு இன்னொரு equation. What is that? It is nothing but NE. I hope you guys remember. And E என்ன? It is nothing but 1.6 into 10 to the power minus 19 coulomb da. In the value வந்து இந்த chapterல கூட தேவையா இருக்கு. Okay, so you have to study this value. Yes, very good Akshara, very good. Okay, so the value will be coming as now coming to the unit of current. So we know that current order unit சொல்லும்போது charge divided by time இல்ல. So tell me what is the SI unit of charge? What is the SI unit of charge? Tell me. இப்போ வந்து கரண்ட்க்கு equation இருக்கு Q by T தான். Q னா charge தான். அப்படினா charge ஓட SI unit என்ன? It is actually coulomb. Okay. Charge divided by time. Time ஓட SI unit என்ன? Second. So I will be getting the unit as coulomb per second. Very good Hali, very good Pradeep. Okay, yes Hariharan. So right now enna pannalam, we can just write this 1 coulomb per 1 second, we can just write it as ampere. Usually we will be using this expression. Okay, ampere da we will be used as the unit. Now coming to the direction part of current. Okay, so right now direction சொல்லும்போது basically we will say that the direction of current na the direction of positive charges oda flow da. Okay, so current oda direction நீங்க வந்து find பண்ணனும்னா positive charges oda flow direction பார்க்கலாம். Where these positive charges are moving and the same direction la da current oda direction கூட இருக்கும். Clear arika? So what is the direction of current? It is actually the thing is like positive charges oda flow oda same direction da. Ana vanda we know that basically in the chapter la pesumbodhu we know that we will be talk about in terms of conductors. Okay, in terms of conductors da we will study. Correct? Okay, we will be studying about conductors. Conductors na metals, right? So metals la enna ஆச்சு அங்க வந்து positive ions na அவங்க வந்து immobile da. So conductors la enna இருக்கு positive ions na it is actually immobile. Immobile na என்னடா? Can you please let me know? இப்போ வந்து நான் வந்து positive charges, I'm talking about positive charges. Okay, so conductors la இப்போ நீங்க வந்து if you are talking about the positive charges na அது வந்து immobile. It is actually it cannot move anywhere. அப்படினா you cannot just talk about the what to say நம்ம current oda flow வந்து சொல்ல முடியாது இல்ல. So அதனால we can just redefine this. Okay, we can just redefine this in a way that if you are taking as positive charges oda flow illana you can just take the opposite flow or let's say opposite direction of electron flow illana negative charge flow. Okay, positive charge இப்படி போயிட்டேனா negative charges electrons will be moving in this line. Correct ah? அப்படினா positive charges oda direction la da current oda direction. அப்படினா எனக்கு சொல்ல முடியும்ல electrons இப்படி போயிட்டேனா இதோட opposite direction positive charges அங்க வந்து move பண்ணலனா you can do one thing, you can just take the electron oda flow and அந்த electron oda flow oda opposite direction la da நம்ம what to say opposite direction la da actually current oda flow இருக்கு. Clear ஆ இருக்கா? Everybody understood? Please let me know. Yes, very good Christopher, very good. Yes da Pradeep, yes. Okay, and guys don't forget to like the session and also share with your friends. Marakama channel subscribe panniko. Now thank you da Hali. Okay, now வந்து I'm going to discuss one more thing. இப்போ வந்து currentக்கு magnitude இருக்கு. Usually வந்து we will say that 3 ampere, 4 ampere, 5 ampere. Okay, இப்போ வந்து we said it is having direction as well. அப்படினா எனக்கு இருக்கிற question என்னன்னா is it a vector quantity? Is it a vector quantity? ஏன்னா வந்து usually we will say na vector quantity na என்ன அதுக்கு வந்து magnitude இருக்கும் direction இருக்கும் அப்படினா என்னோட question வந்து current வந்து ஒரு vector quantity யா இல்ல it is actually a scalar quantity. That is what the confusion that I have. Now can you please let me know? Is it going to be a vector or a scalar quantity? Current is a scalar quantity. Yeah, ma'am, adukku direction irukku, adukku magnitude irukku, then also you are saying that it is having, it is a scalar quantity. So basically சொல்லும்போது right now நம்ம current ல we know that if you wanted to call a vector as a vector, I mean a quantity as a vector quantity, first of all நீங்க வந்து என்ன பண்ணனும்னா you have to check the magnitude, you have to check whether it is having direction. Another thing is there, it should obey vector algebra. Okay, while we add, like the way we will be adding forces and all, no, how we used to add? So ipo vanda forces different ana direction la irukira forces na and the direction la da we will consider, correct? Okay, so right now for example ipo vanda enakku vanda oru board inge irukku, okay, 3 Newton force is acting in this direction, 4 Newton force is acting in this direction. Ipo vanda na kekka porom, what is the net force acting on this body? அப்படினா நீங்க வந்து சொல்லுமா 3 plus 4 7 Newton ma'am அப்படி சொல்ல முடியும்ல. Okay, we cannot just say that, correcta? We cannot just say that. We will say that 3 Newton in the positive x direction, 4 Newton in the y direction. It will not cancel each other. We cannot add this in two direction because one is along x direction, one is along y direction. We cannot add this. Clear arika? So because the thing is like it is obeying vector algebra. Same direction la irukra quantities mattum da nammalaala வந்து டைரக்டா add and subtract பண்ண முடியும், இல்லனா முடியாது. Clear ஆ இருக்கா? Everybody understood? Yes or no? Can you please let me know? So இப்போ வந்து I have told you one thing, current na என்னடா ஒரு scalar quantity da. It is having magnitude, it is having direction, ஆனா வந்து it does not obey what? Vector addition rule. Clear arka? Clear arkada everybody? Can you please let me know? So right now we were talking about the current electricity chapter. Adula vandu we were just started about talking about current. Current na enna? Charges oda flow oda rate da actually vandu current. And the current we have two types of current, average and instantaneous current. What is the major difference between these two currents? Can you please let me know? Those who have attended, can you please let me know in the average and the instantaneous current oda major ana difference enna? Instantaneous current na exactly in the fraction of second illa what was the current, illana how much charge was flowing in that particular instant. And average சொல்லும்போது it is basically for a longer interval, and அந்த longer interval ல different ஆன positions ல different ஆன flow தான் இருக்கும். ஆனாலும் we will say that, okay, for example now வந்து I'm going to ask you, let us say you are just coming from home to the school, okay, so you will not maintain the same speed, I mean throughout the journey, right? நீங்க வந்து first few minutes ல நீங்க வந்து ரொம்ப fast ஆ இருக்கலாம், இல்லனா கொஞ்சம் slow ஆ இருக்கலாம், again fast, slow, depending upon the vehicle, depending upon the crowd, உங்க speed வந்து I mean it will be changed. இப்போ வந்து நான் கேட்க போறேன் exactly இந்த particular secondல உங்க speed என்னாச்சு? That is what instantaneous. ஆனா வந்து நான் கேட்க போறேன், okay, so while you are coming, what was your speed? So அப்படினா உங்களால வந்து சொல்ல முடியாது, எக்ஸாக்ட்டா ஒரு வேல்யூ வந்து சொல்ல முடியாது. So you will be finding, okay, so average வந்து almost I have maintained this range of velocity. அதுதான் வந்து இங்க கூட we have discussed. Clear ஆ இருக்கல? Everybody understood? And now we have understood நம்ம current ஓட unit என்ன? Coulomb per second, இல்லனா we can just use ampere. இல்லனா we can just discuss about the direction. Direction na எப்பவுமே வந்து it will opposite to the flow of electrons ஆ இருக்கும். Why we are saying this? Because ஏனா வந்து conductors ல இந்த chapterல we are focusing on metals. அதனால அங்க வந்து நம்ம positive charges பார்க்கும்போது it is actually immobile, it cannot move, it is restricted. அப்படினா அங்க flow பண்றது வந்து நம்ம free electrons மட்டும்தான். அந்த free electrons னால we should define in terms of that flow of free electrons. So we can say that it will be current order direction வந்து exactly opposite to the flow of electrons தான். Okay, and why it is considered as scalar? Still it is having the magnitude and direction irukku. Then also why we are considering it as a scalar? Because it is not obeying the vector addition rule. Clear arkana? Can you just give me a red heart in the chat box, guys? Everybody. And also we know this is also one of the equation we used to study. It is NE by T da. Correct arka? Thank you da. Thank you Hali. Thank you Hariharan. Thank you so much. Okay. So right now we have studied I is equal to dq by dt da. அப்படினா எனக்கு I just wanted to cross multiply this. அப்படினா எனக்கு என்ன கிடைக்க போறோம்? I will be getting dq ஓட expression. dq ஓட expression என்னடா? It will be I into dt. இப்போ நான் I'm going to integrate both the sides. அப்படினா எனக்கு என்ன கிடைக்கும்? I will be getting delta q, or let's say the total charge flow I will get. Okay, அப்படினா நான் I'm going to do one thing da. Just understand. இப்போ எனக்கு ஒரு graph இருக்கு, இங்க I இருக்கு, இங்க time இருக்கு. Okay, so right now இப்படி தான் என் graph. So now I'm asking you, what is the area under this IT curve? Okay, what is my question? Area under the IT curve, current time graph. What is the area? To find the area, what we should do? We should integrate. And while we integrate I dt, what we will be getting? We will be getting delta q. So what is the area under the IT curve? It is nothing but, IT current. Okay, IT curve da, which is nothing but delta q. Clear arkada? Everybody understood? Please let me know. We will be getting delta q. Right now now we have written this I average illa, adula innum modify panna porom. Okay, modify enna delta q க்கு இப்போ we got another equation. What was that? இப்போ delta q na what we have mentioned, this is nothing but the area under IT curve. Correct alla? So can I just use this equation? I average na enna? இப்போ I have given current and time oda graph. adula irundha I am asking you average current find பண்ணனும். அப்படினா நீங்க என்ன பண்ணனும்? First நீங்க you have to find delta q. ஏனா delta q direct அந்த graphல இல்ல. Okay, you have to find the area under the IT curve. அந்த area find பண்றதுக்கு அப்புறம் you have to divide it with the time interval. Then you will be getting the average value. அப்படினா நான் I'm just going to substitute area under the IT curve na enna? I dt divided by delta t I can just rewrite it as integral dt. Okay, illana you can just write it as delta t itself. Clear? Can you please respond? Everybody. And guys, don't forget to like the session. I want more likes from you people. You people are not liking, which I don't like. Okay, clear? Perfect. Everybody. Yes, in IT graph, area under the IT curve will be coming as charge. Okay? Yes, thank you, Hali. Thank you so much. So right now, this is what the thing. So in our equation, if I wanted to teach now, let us say, the charge is rotating. Okay, we have a charge E that is rotating. It is moving in a circular path. And the time, what is going to be the current? Okay, so now I'm just going to write the current due to rotating charge. Current due to enada? Rotating charge. So right now general expression enna? I which is equal to q by t. Ana idu a circular motion. So let us say if the charge E is starting from this point and it is completing one circle, now what is the time taken? Can I say that t is equal to capital T? What is capital T? Can you please let me know? Thank you, Hariharan. Thank you, da. So tell me, da, if what is capital T? Capital T in a time period. What is time period? What is time period? Tell me. Time period na the time taken for that particular charge to complete one circle. Correct? Time period na enada? The time taken for completing one circle is known as the time period. அப்படினா நான் வந்து ரீப்ளேஸ் பண்ண போறோம் ஓகேவா q வந்து சார்ஜ் வந்து இந்த கேஸ்ல e தான் so e divided by t now எனக்கு வந்து t தெரியாது ஆனா வந்து எனக்கு வந்து angular velocity தெரியும் omega value I know okay I don't know this t value I only know omega அப்படினா can you just let me know in the time period and omega connect பண்ற அந்த equation கொஞ்சம் சொல்ல முடியுமாடா time period and this omega ஓட connecting relation everybody know it what is that t is equal to 2 pi by omega அப்படினா நான் வந்து இங்க substitute பண்ண போறோம் e divided by 2 pi by omega so that will be coming on the top for any charge you can just replace this e ஏனா வந்து இங்க இந்த கேஸ்ல I have written it as one electron so you can just write it as q omega divided by 2 pi is the current for a rotating charge clear arika everybody understood please let me know please let me know da very good Pradeep very good Hali yes yes da guys don't forget to like the session please everybody like the session and also share with your friends so right now எனக்கு வந்து omega கூட தெரியல okay I only know in the circle ஓட radius தெரியும் r and also இதோட linear velocity தெரியும் v clear so இப்போ வந்து எனக்கு வந்து இன்னொரு problem இருக்கு so I know right now rotating charge na adu current I can find in terms of time period in terms of angular velocity now the thing is like in the time period and angular velocity எனக்கு தெரியாது what I know only r and v the radius of that circular path and the velocity I know அப்படினா என்ன பண்ணலாம் again we will be using the same equation okay again you will be using the same equation I which is equal to q by t da q னா என்ன te தான் கரெக்ட் இல்ல டைம் பீரியட் எப்படி ஃபைண்ட் பண்ணலாம்டா டைம் பீரியட் எப்படி ஃபைண்ட் பண்ணலாம் வெரி குட் பிரதீப் வெரி குட் டைம் பீரியட்னா அதோட ஈக்குவேஷன் என்ன the distance traveled divided by velocity இல்லனா ஸ்பீட் தான் கரெக்ட் இல்ல அப்படினா டிஸ்டன்ஸ்னா என்ன இப்போ வந்து ஒரு பார்ட்டிகல் is completing one circle na what is the distance traveled can you please let me know இப்போ வந்து ஒரு பார்ட்டிகல் இருக்கு if it is completing one circular path na what is the distance traveled distance will be nothing but 2 pi r very good Hali so right now I can just write it as 2 pi r and velocity is given now I'm going to substitute here e divided by 2 pi r divided by velocity will come on the top so I'll be getting ev by 2 pi r clear so இது வரைக்கும் whatever we have studied அது வந்து கொஞ்சம் summarize பண்ணலாமாடா so basically வந்து we were just still stuck with the current part so electric current னா என்ன it is actually the flow of charges with respect to time da so right now we have the average current சொல்லும்போது it is nothing but delta q divided by delta t which means it will be having a longer time interval okay right now we know that in the delta q if we have a iv graph okay sorry it graph irundiruchuna how you will replace this we will be writing area under the it curve divided by the time interval அப்படினா நான் வந்து கொஞ்சம் ரீப்ளேஸ் பண்ண போறோம்டா this will be coming as I dt divided by integral dt னா அந்த time interval அவ்ளோதான் இருக்கு ஏனா வந்து integral dt ல நீங்க வந்து இந்த limits apply பண்ணிட்டேனா you will be getting the time interval right t2 minus t1 integral dt na t limit apply பண்ணும்போது t2 minus t1 அவ்ளோதான் guys don't forget to like the session this is what the first part அதுக்கப்புறம் instantaneous okay instantaneous current தான் instantaneous current சொல்லும்போது it is for a particular second okay it is for a particular second or a fraction of second சொல்லலாம் this will be coming as dq by dt this is basically the slope of நம்ம qt graph okay நம்ம qt graph இல்லனா qt curve ஓட slope தான் வந்து இந்த instantaneous current okay இதுக்கப்புறம் we were discussed about the unit of the current, which is nothing but coulomb per second, or we can say that usually we will be using ampere. And current is a scalar or a vector quantity da? It is actually a scalar quantity da, because what is the reason? இப்போ வந்து we know that current it is having magnitude, it is having direction, ஆனாலும் it does not obey the vector addition rule, so அதனால it is considered it as a scalar quantity. And what is the direction of current? Direction of current, it is nothing but opposite to the flow of electrons. Correct illa? It is exactly opposite to the flow of electrons. Yes, tavas, yes. Okay, so right now we have the direction of the current, which will be coming as opposite to the flow of free electrons. Why we are considering it as opposite to the flow of electrons? Because the reason is, in conductors, these electrons only actually mobile are, which means it can only move. Positive charges it will be coming as it cannot move, it is immobile da. Correct? And guys, don't forget to like the session. So now we got all the equations. Idu mattum illa, current ku different ana equations kuda we have written. I is equal to Q by T, and that is also equal to NE by T. And for a rotating charge, E, or let's say Q, we can say that current will be coming as Q by time period, or Q divided by 2 pi r into V, or let's say Q omega divided by 2 pi. So we have different types of equations. Clear, Arikada? Yes, Pradeep, Kamaraj, Abhinaya, everybody understood? Any confusion so far? So these are the things we have studied till now. Now we are going for the another part of this chapter. Okay, current vanda clear ah, you got it? Okay, illada dq by dt na, it is actually the slope of qt graph. Okay, so slope சொல்லும்போது what has happened in the y axis, what has happened in the x axis, அதோட ratio da. So இப்போ வந்து q and t graph இருக்கும்போது Q and T mark பண்ணிட்டேனா, what is changing in the y axis? Delta Q. What is changing in the x axis? Delta T. So delta Q by delta T. இல்லனா smaller interval if you are taking na, dq by dt. அது வந்து நமக்கே தெரியும், it is actually current da. Clear? Everybody, please let me know quick. Okay, so now we are going for something different. Okay, so just give me a second, guys. Okay, so right now what we are going to do, we have a conductor over here. Okay, so ipo vanda namakku enna irukida, we have a conductor over here. So in the conductor la neenga vandu paathena, we know that there is a lots of free electrons irukum. We know conductors la enna irukum, free electrons irukum. So in the free electrons paakumbodhu, I can ask you one thing. So let us say idu vandu oru conductor da. Okay, so we know that ipo vandu charges oda flow irundiruchina, anga vandu current will also be there, right? Okay, if you are talking about what, if you are talking about free electrons, in the conductors kulla free electrons irukumla, அப்படினா my question is, this conductor, okay, inside this conductor in the free electrons வந்து move பண்ணுமா இல்லையா? Tell me quick. Omega equal to 2 pi illada, omega is equal to 2 pi by t da. Okay, simple sollada. Okay, so my question is, inga வந்து இந்த electrons will move or what? So let us say unga answer vanda maybe yes ah irukkalam, no ah irukkalam, let it be. Another question, ipo vanda flow irundiruchina, okay, ipo vanda இந்த electrons oda flow irundiruchina, anga vanda current irukumla, அப்படினா நம்ம வந்து if you are touching on the conductor, we should get the shock. Correct? Yes or no? So if it is moving, okay, in the conductors kulla in the electrons were moving na, okay, conductors kulla electrons vanda moving na, we can say one thing, இப்போ வந்து அங்க வந்து current will definitely come. அப்படினா when we touch இது வந்து drift velocity இல்லடா, wrong answer. Okay, so when we touch we should get shock. ஆனா வந்து it is not happening. So basically இந்த conductors குள்ள என்ன இருக்கும், இந்த electrons will move in random direction. Okay, electrons will move in. Okay, we are not applying any electric field, nothing. Okay, அந்த டைம்ல what will happen, this free electrons will move randomly. Okay, will move randomly. This is what the first point. Okay, so right now என்ன இருக்கும், இப்போ வந்து இந்த எலக்ட்ரான்ஸ்க்கு எல்லாமே வந்து இண்டிவிஜுவலா ஐ அம் ஜஸ்ட் ஃபோக்கஸிங் ஆன் ஒன் எலக்ட்ரான். இந்த ஒரே ஒரு எலக்ட்ரானை நான் வந்து ஃபோக்கஸ் பண்ணிட்டேனா, அந்த எலக்ட்ரானுக்கு ஒரு வெலாசிட்டி இருக்கும்ல, that will be come around 10 to the power 6 meter per second. Just understand this power. Okay, இப்போ வந்து இந்த ஃப்ரீ எலக்ட்ரான்ஸ் பார்த்தேன், இந்த ரேண்டம் மோஷன்ல இருக்கிற இந்த ஃப்ரீ எலக்ட்ரான்ஸ் பார்த்தேன்னா அந்த எலக்ட்ரான்ஸுக்கு அரௌண்ட் 10 to the power 5 to 10 to the power 6 meter per second ஸ்பீட் இருக்கு. ஆனா அது there is no use of it. ஏன்னா வந்து இப்போ வந்து if you are just talking about the total, okay, நான் வந்து if I focused only on one electron, right, இந்த மாதிரி நிறைய ஃப்ரீ எலக்ட்ரான்ஸ் இருக்கு. Everything is just going like this. இப்படிதான் it was just going for random motion. அந்த random motionனால what will happen, அந்த random motionனால when it comes to the net displacement, okay, when it comes to the net displacement, it will come as 0, which means one free electron will collide somewhere, it will go like this, it will come back to the original position. Okay, அதோட initial positionல it will come back. அப்படி it is coming back na என்ன ஆகும், net displacement வந்து 0 ஆகும். அப்படினா I can say that the thermal velocity, the average of thermal velocity will come as 0. Okay, so when I'm talking about each of the free electron, one by one talking na, ஒவ்வொரு ஃப்ரீ எலக்ட்ரானுக்குமே அதுக்கு இருக்கிற கைனெட்டிக் எனர்ஜி இல்லைன்னா அதுக்கு இருக்கிற வெலாசிட்டி வந்து இட் இஸ் கம்மிங் அரௌண்ட் 10 to the power 5 to 10 to the power 6 தான். அவ்வளோ ஸ்பீட் இருக்கு இண்டிவிஜுவல் எலக்ட்ரானுக்கு. ஆனா நான் வந்து ஐம் ஜஸ்ட் கன்சிடரிங் ஆல் த எலக்ட்ரான்ஸ் பார்க்கும்போது when I'm just taking the average velocity of all these electrons, I will get 0. Clear arcade in the concept? This is not drift velocity, this is what the thermal velocity. And this is not contributing to the current. Okay, not contributing to the current. Thermal velocity is not contributing to the current. So this is what the thing, thermal speed, it will be coming around 10 to the power 5. Okay, you can just keep it as 10 to the power 5. So we have a conductor, and the conductor kulla free electrons irukku, and the free electrons are in random motion, and each and every electron is having a velocity which is approximately 10 to the power 5 meter per second. Ana vandu due to the random motion nala the net displacement will be coming as 0. So when I am taking the average velocity, I will be getting 0. Understood na? Can you just respond with your green heart, everybody? Please quicker. Quicker respond பண்ணுடா. என்னாச்சு காமராஜ்? Yes, coming to it. Guys, don't forget to like the session and also share with your friends as well. This is happening in the absence of electric field. Now the story will change in the presence of electric field. Again, we have the same conductor with the same number of free electrons. Ana, the thing is, like, let us say if I'm just keeping the electric field in this direction. Okay, if I'm keeping the electric field in this direction, these electrons will move towards this direction. And now the electric field will be always from the positive to the negative terminal, right? Okay, அப்படினா என்ன ஆகும், electrons எப்பவுமே வந்து positive, it is having an attraction towards the positive side. So அப்படினா இங்க தான் வந்து நம்ம positive side, so electrons will move towards the positive side. Okay, so இது வந்து straight line motion இல்ல. Okay, it is not going to be a straight line motion. ஆனாலும் I can make sure one thing, it will never come back to the initial position. Clear ஆ what I said? So I am talking about the free electrons. In the free electrons, இப்போ வந்து நான் வந்து ஒரு electric field வந்து apply பண்ணிட்டேனா, it will move towards one direction. ஆனா அது வந்து straight line ல it is not going to go. Okay, it will never go in a straight line. Okay, in the electron will never go in a straight line. It is going to be a parabolic path. ஆனாலும் I can say one thing. Okay, இந்த electron வந்து இங்க இருந்து start பண்ணிருக்கேன். Okay, it will go like this and it will never come back to this. Okay, it will only move forward. Clear ஆ everybody please respond. So right now நம்ம electrons ஓட flow தான் வந்து we were just talking. So in the electrons will move in one direction so that it will have some velocity. Okay, in the presence of electric field it will be having some velocity, and that velocity we will be call it as what? It is nothing but the drift velocity. Okay, what is that? It is nothing but the drift velocity. Clear ஆ in the drift velocity in the presence of electric field, the electrons will align and it will move towards one direction, and the velocity of that electrons during the presence of electric field, which is known as drift velocity. Okay, and this drift velocity is actually always what will be the direction? Always opposite to the direction of what? Can you please fill it? Direction of electric field. Okay, electric field வந்து positive x direction னா drift velocity ஓட direction எப்படிடா? Can you please let me know? How will be the direction? Opposite to the field da. So we can say that negative x axis da it is going to come. And இதோட ஒரு range வந்து 10 to the power minus 4 meter per second. You see, in the thermal velocity ஓட range என்ன சொல்லிருக்கேன்? 10 to the power plus 5. ஆனா வந்து இங்க என்னாச்சு? நம்ம drift velocity ஓட speed என்ன? 10 to the power minus 4. அவ்வளவுதான் இருக்கு. Drift தான் பண்ணுவேன். Okay, it is actually very less, very less number. Okay, 10 to the power minus 4 meter per second தான் அதோட range வருது. Clear ஆ everybody understood? And also இதோட mathematical expression வந்து minus EE by M tau. Okay, அப்படினா நீங்க வந்து you will ask, what is tau ma'am? What is this letter? Okay, இதுல வந்து E எனக்கு தெரியும், capital E தெரியும், M தெரியும். What is this tau? Can you please let me know? What is this tau? This is what the relaxation time. Okay, இது என்னடா? இது வந்து nothing but the torque. Okay, so right now this is nothing but the relaxation time na நம்ம day to day life la let us say you people will be fighting with your siblings illa. Okay, so அந்த டைம்ல one fight is over, அதுக்கு அப்புறம் கொஞ்சம் டைம் இருக்கும்ல next ஃபைட்டுக்கு முன்னாடி. Okay, so அந்த resting time தான் actually வந்து relaxation time. For example, let us say if I am just talking in this terms, okay, நம்ம whatever we are studying அதோட பேசிஸ்ல சொல்லிட்டேனா we can say that definitely electron will collide, then again collide, multiple collisions will happen, right? Okay, so I can say that the average time between two successive collisions, okay, first collision is over, second collision is over, what is the average time between this? Clear arika? So what is relaxation time? The average time between the two successive collisions is known as the relaxation time. And this is the very small value. Approximate order will be 10 to the power minus 14 seconds. What is the approximate value? 10 to the power minus 14 seconds is the actual nama relaxation time order value. Clear arika? So right now drift velocity we got an expression, and we got what is relaxation time, and the time actually what is going to be the range வந்து clear ஆ நமக்கு வந்து கிடைச்சிருக்கு. Okay, everybody understood everybody? Okay, so இன்னொரு term இருக்கு. Yes, very good Abhinaya, very good, very good. So இன்னொரு term இருக்குடா, that is what the mean free path. Okay, what is mean free path? That is again a very simple concept. Okay, yes da Hali, thank you. Balraj, right? Yes. Okay, so right now when we are talking about relaxation time வந்து clear ஆ இருக்கே. So next வந்து mean free path தான். So basically சொல்லும்போது we know that let us say this will collide, multiple collisions will happen, let it happen. So now the thing is like the total distance traveled divided by number of collisions பண்ணிட்டேனா எனக்கு வந்து ஆவரேஜா in between two collisionsல எவ்வளோ distance travel பண்ணியிருக்கேன் அது வந்து எனக்கு கிடைக்கும்ல. Just understand. Okay, I'm just traveling from here to there. Okay, so first collision happened, second collision happened, third collision happened, fourth collision happened. So இப்படியே இந்த collisions, multiple collisions is happening. Now I'm giving a value, the distance, the total distance I have traveled divided by எவ்வளோ collisions happen to me, number of collisions. அப்படின்னா what you're getting, okay, so basically வந்து average distance between two successive collisions I will get it, right? Okay, first collisionக்கு அப்புறம் இன்னொரு collision, அதுக்குள்ள எவ்வளோ time, எவ்வளோ distance வந்து travel பண்ணியிருக்கேன், I will be get it, right? Clear? So that is what the mean free path. Usually we will represent it as lambda. Okay, what is mean free path? The total distance traveled divided by the number of collisions. Okay, so now we have done that as well. Now another thing is like we just wanted to study another term. Okay, another term. What is that? Have you heard about this current density? So right now the thing is like we know current வந்து என்ன ஒரு scalar quantity தான். அப்படினா எனக்கு current மாதிரி ஒரு vector quantity கிடைக்கணும். அப்படினா அந்த vector quantity, okay, that is what actually the current density. So the current density will be it is actually a vector quantity and this is equal to, we will usually represent it as J divided by A. Okay, so current divided by area will give me the J value. Okay, so now I'm just going to cross multiply this. So what I will be getting, J dot A, which is equal to I. Correct illa? அப்படினா J dot A, dot product of two vectors, what is, how we can just write it? J A cos theta will be coming as I. So I'm getting the current dot expression. If you know the area, if you know the current density, if you know the angle between them, you can just find the current dot value, which is nothing but J A cos theta. Clear arika? Everybody understood? Can you please let me know what is going to be the unit of this current density? Konjam solla mudiyumada? Unit of current density simple da irukke. Current na enna ampere, area na enna meter square. So what will be the unit? It will be coming as ampere per meter square as the unit, and it is actually a vector quantity da, and its direction is the direction of motion of positive charges at that point. Okay, that is what the thing. Now the thing is like you have to study some relations. So you can see NEET exam la ninga vanda ovvoru, okay, you are just taking every alternative years la at least vanda in the equations based on questions ketite irukku. So now I'm going to teach you some of the equations. I which is equal to NAVD. Okay, wow, this is what the first equation, connecting the relation between current and the drift velocity. Okay, yes da Abhinaya, very good. Hali, very good. Hariharan, Pradeep Kumar, very good. So I which is equal to NEAVD. This is what the relation connecting current and the drift velocity. Appadina suddenly what I'm going to do, I'm going to take this I over here, which means I by A. What is I by A? It is nothing but J. So this will be equal to the rest of the part, which means NEVD. Okay, so right now VD, drift velocity na basically ennada, drift velocity na enna, displacement by time dana. So displacement na enna, ipo vandu or conductor, if you are just taking the conductor, this is what the conductor you have. So ipo vandu idoda length vandu L da, And now if I'm asking you, now if I'm telling you one electron will take t time to reach the other end. Okay, one electron is starting from this point and it will take some t time to reach this point. Okay, appadina what is drift velocity? What is drift velocity? How we can say drift velocity? Drift velocity na, it will be coming as the displacement, which is L, divided by the time. So if you wanted, you can just, depending upon the questions, depending upon what is the values are given, so அதோட பேசிஸ்ல உங்களுக்கு வந்து you can just write it like this. Clear இருக்கா? Everybody understood? Please let me know. So this is what the another equation we should study. இப்போ வந்து Ohm's law study பண்றதுக்கு அப்புறம் we will study more equations relating J, VD and everything. So just wait for that. Right now we have studied the relation connecting VD and the current as well as J and the thing. Now இன்னொரு equation is nothing but mobility da. Mobility is nothing but the modulus of drift velocity per unit electric field. Okay, so another equation for the another term is nothing but mobility. Mobility is nothing but VD by E da. So VD oda expression வந்து we already studied, E by M2 divided by E. What will happen? This E, this V will be get cancelled and you will be getting E tau by M you will get. So mobility, you have another equation as well. Clear arika? So now are you guys ready for a question? Let us do some questions. Ready? Yeah? Ready? Now put some fire in the chat box quickly. And don't forget to like the session. Don't forget to like the session. And also, if you're ready for the question practice, put some fire in the chat box, everybody. Yes. So now we are going for the first question. Yes. Okay, so you guys have to be very much focused for solving the questions. எப்பவுமே வந்து யூனிட் செக் பண்ணி தான் நீங்க வந்து ஆன்சர் பண்ணணும். ஓகே, ஸோ இம்மிடியேட்டா ஆன்சர் பண்ணாத. whenever you are feeling like okay இது வந்து இதுதான் வந்து சான்ஸ் அதிகமா இருக்கு, ஸோ அப்படி ஃபீல் பண்ணும்போது you just mark it. drift velocityயோட ஆர்டர் தான் கேட்டிருக்கேன். என்னடா இது? First of all, we know that drift velocity na அதோட பவர் வந்து மைனஸ்ல தான் இருக்கு. கரெக்டா? Yes or no? Please let me know. இப்போ வந்து நான் வந்து drift velocity சொல்லிட்டேனா அதுல வந்து நான் வந்து கிளியரா சொல்லியிருக்கேன். It is actually பவர் வந்து நெகட்டிவ் தான். அப்படின்னா எனக்கு வந்து this I can remove, this I can remove. And what is the range I have mentioned? 10 to the power minus 4 meter per second. ஆனா இங்க வந்து எந்த யூனிட்ல they have given da? It is given in terms of centimeter per second. அப்படின்னா I can just write it as 10 to the power minus 2 centimeter per second it will come. So I can say that option B will be the right answer for this particular question. Clear arkada? Clear ina konjam green heart poda mudiyumada? Everybody, I need some green hearts please. Perfect. அப்படினா we are going for quicker, we are going for the next question. So in the question பண்ணலாம். I'll be giving you 1 minute of time. So you can just do it. கொஞ்சம் time you have to take and you have to do, okay? Don't do it quickly. Everybody. Very good, very good, very good. Right answers are coming. Very good. Super da. Okay. So now let us do this. So இப்போ நீங்க வந்து பார்க்கும்போது what is given in the question? A conductor carries a current of 0.2 ampere in 30 seconds. How many electrons will flow? Number of electrons தான் கேட்டுட்டு இருக்கேன். கரெக்ட் இல்ல? So அப்படினா we know that current which is equal to Q by T தான். ஆனா வந்து Q க்கு இன்னொரு expression we have studied, that is what NE. அப்படினா questionல என்ன asked-டா? They have asked what is N. So அப்படினா I is equal to NE by T da. So I'm just keeping that N over there. Correct? How many electrons will flow? So I into T divided by E will be coming as N. So I oda value வந்து 0.2 da. And T வந்து என்னடா? T value என்ன? 30 seconds. Divided by E value, sometimes they will give, ana vanda we cannot just make sure, okay, all the time they will give, and the madri we cannot just make sure, okay. So you have to study the value. 1.6 into 10 to the power minus 19, it will come. Okay, va? Clear arika? Everybody, can you please let me know? So this will be coming around 4 into 10 to the power 19. So we can say that close value will be coming as 3.75. So as usual, how we will be taking the approximation. Vetri students will definitely do, I'm damn sure. So இப்போ வந்து பார்க்கும்போது 0 into 2 into 30, which will be coming as 6. 6 divided by, you can just approximate to 1.5, which means 15. So 60 divided by 15 பண்ணலாம். So you know that will be coming as 4 into 10 to the power 19 it will come. And the closest value, we have done an approximation. So closest value will be coming as what? We will be getting 4. Appadina, in seconds, we can just do the calculation. Clear? Everybody understood na? Konjam the blue heart poda mudimada? Everybody? If you understood, can you give me a blue heart? Yes. And guys, don't forget to like the session. Shall we go for the next question? Okay, options adulla. Okay, so appadina simple irukumda. Charge passing through a conductor of cross sectional area A, which is equal to 0.3 meter square, and Q is given, and where T is in seconds, what time the current will not flow? Okay, again I'm going to give you some time da. I'm going to give you 1 minute of time. You have to tell me what is the answer for this particular question. Right answers ellam varudha. Super da. Waiting for others' answer. Very good, very good, very good, very good, Apnaya. Very good, Pradeep Kumar. Very good. So let us do it. So இப்போ வந்து questionல charge is given. Charge ஓட value என்னடா 3t square minus 5t plus 2 தான். So we need to find the current at which it will become 0. Current 0 ஆகுற அந்த time தான் தெரியணும். So அதுக்காக first I need to find the time. எப்படி find பண்ணலாம்? Sorry, I need to find the current. எப்படி current வந்து find பண்ணலாம்டா? How we can just find the current? It is simply dq by dt இல்ல? We have studied this equation. Correcta? And guys, don't forget to like the session. Okay. So appadina we can say that d by dt of 3t square minus 5t plus 2. So இப்போ வந்து என்ன பண்ணலாம்? Tell me da, what is d by dt of 3t square? 3 வந்து constant da. So you need to differentiate t square. அப்படினா என்ன ஆகும்? அந்த value என்ன? d by dt of 3t square. d by dt of 3t square. அப்படினா this will be coming as 60 and minus what is d by dt of 5t? What is d by dt of 5t? Very good, Hali, very good. So it will be coming as 5. And now again going back to the question. At what time? What will be, I mean, when the current will be 0. Current is 0 ஆகிற moment. So I am just substituting. Current வந்து எனக்கு கிடைச்சிருக்கு 60 minus 5 தான். அப்படினா இது வந்து 0 ஆகிற moment எல்லாம் கேட்டிருக்கே. So now I'm going to do 60 minus 5. So minus 5 will be going on that side, which will become plus. அப்படினா t will become 5 by 6. So this will be coming approximately 0.83. Clear Arikada, everybody? Can you please let me know in the chat box with a pink heart, everybody? With a pink heart. Everybody? Yes, da. Thank you, Hali. Yes. So now we are going for the next question. So directa irukra question da. So neenga vandu you will quickly give the answer. So tell me. Determines the current. Simple question. Why we not use 0.3? 0.3 எதுக்கு யூஸ் பண்ணணும்டா? அது வந்து ஏரியா இல்ல. That is not, இதுக்கு வந்து தேவையில்லைன்னா why we are just thinking about it? Very good Pradeep, very good Hali. So current na அது வந்து drift velocity தான். ஏனா வந்து we know that thermal velocity current ல zero contribution தான். Okay, thermal velocity க்கு வந்து current க்கு zero contribution மட்டும் தான் இருக்கு. So I can say that whenever we are talking about the velocity and which is contributing to the current, it is only the drift velocity மட்டும் தான். Okay, so now we are going for the another question. Okay, can you just do this question? Simple irke calculation ellame vandu simple da irke. A charged particle having drift velocity 7.5 into 10 to the power minus 4. Electric field is 3 into 10 to the power minus 10. What is the mobility? Again, very simple question. Of course, yes, students vandu they will definitely do it. Enakku theriyum adu. quicker you can do it. Very good. Super da. So right now we know that mobility da it is asked. Mobility na drift velocity divided by electric field da. So in the two values vandu you can just divide avlo da. Okay. So while you divide, yes, just division avlo da irukke. So what will be the answer coming? We will be getting option A as the answer. Clear இருக்கடா? இதுல வந்து கன்ஃபியூஷனுக்கு எதுவுமே இல்ல. equation தெரியும், substitution, mathematics தெரியும்னா அவ்ளோ ஃபாஸ்டா உங்களுக்கு வந்து question solve பண்ணலாம். Now we are going for the next question. And guys, you people are not liking the session, okay? இது வந்து NEET previous year question அபிநயா. Waiting for everyone's answer. Quick-ஆ சொல்லடா. Okay, everybody. Konjam calculation error irukkalamda. Konjam you have to do it. Check பண்ணுடா. Okay. So right now we are going for it. The number of density is given as, it is given as what? I can't read it. 8.5 into 10 to the power 28. Okay. And how long does the electron take to drift from one end of the wire, and it is having a length 3 meter to the other end. So time தான் நம்ம வந்து find பண்ணணும். And the cross section is, area is given as 2 into 10 to the power minus 6. Current is given 3 ampere. Okay, so this is what the given data, we need to find the time. So அதுக்காக which equation we can use? We can just use the equation relating current and drift velocity. அதுல வந்து நான் சொல்லியிருக்கேன்ல drift velocity வந்து we can just rewrite, correct? So we can just go for NEAL by T. So இதுல வந்து இந்த T value தான் questionல கேட்டிருக்கேன். So now T will be coming as NEAL divided by I will come. So 8.5 into 10 to the power 28 into E value வந்து 1.6 into 10 to the power minus 19 into area வந்து 2 into 10 to the power minus 6 into L length வந்து 3 divided by current 3. Okay, so this is what the substitution we have to do. Okay, so the in the 3 will be get cancelled. Again we have 1.6 into 2 into 8.5, and we have the powers to balance as well. Now while we do, we will be getting option A as the right answer for this particular question. Clear arkada? Everybody, can you please let me know? Can you please let me know? Session one, it will go around like 9 o'clock. Da. Okay. Should we go for a break right now? Are you guys ready to continue with the Ohm's law, or next topic munnadi konjam oru break venuma? Because anyway, I was planned to give 1:15. Okay, and the time I will just plan to give a break. Illana continuous, if you are just sitting na, you will feel like, oh my god, enna idu and madri you will feel. Yes, Abhinaya, clear ah irukke. Thank you da. Idu vandu ennada adu vandu represent பண்றது bubbles ah? Yes. Mama, ma'am, pasikida. Oh my god. Okay. Then let's have a break da. So idukapram we can just come back by 6:25. Okay. Thank you guys. So after this break, we can just meet again. Okay.
You are done.
Hello everybody, ready ada? Ready na? Konjam fire podida nama chat box la. Let me see. Everybody. We are in fire mode. Okay, yes. So let us just continue. So we have studied about the current density and how in the conductors la eppadi in the current is flowing anga irukira velocities eppadi irukum ellame vandu clear we have discussed. Now we are going for the Ohm's law. So now you guys tell me what is Ohm's law. Quick ah sollada, what is Ohm's law? What you know as Ohm's law? Ohm's law na enna? Tell me, Ohm's law na enna? Ohm's law na very simple. It is nothing but what? Yes. So Ohm's law na enada? The current will be proportional to, illana the potential will be proportional to current. Some conditions are there. And the conditions illana Ohm's law valid illa. Okay. So basically when we are talking about Ohm's law is nothing but the potential difference is proportional to the current if the temperature or let's say the physical conditions are constant. And the condition specified pannalana Ohm's law illa. Adu vandu valid illa. We know that in the Ohm's law it is not actually a universal law as well. Why it is coming as I mean not a universal law. If you are just considering edachu or law neenga you are calling it as universal law na adu ovvoru conditions lume all scenarios la adu valid ah irukanum. Ana when it comes to nama Ohm's law enna irukku? Ohm's law paakumbodhu the problem is like this is valid. Okay, this is valid only for some specific set of things. Temperature is high, it is not valid. And it is also only valid for some devices called ohmic devices. It is something like transistors, diodes, semiconductors. Idellame it is not valid at all. Okay. Done. So now we can say that Ohm's law na enna? We can say that V is equal to I into R. In the proportionality convert panni equal ஆக்குறதுக்கு so to make it equal we are just introducing a constant and the constant தான் நம்ம R. R na என்னடா? Can you please let me know what is R? R na resistance da. இது separate we are going to study. So let it be here right now. So இப்போ என்ன ஆச்சு? Voltage is proportional to current da. அப்படினா நான் கேட்க போறேன்டா, if we have a VI graph, what is the slope of this graph? What is the slope of this graph? Can you please let me know? In the graph oda slope enna? Tell me quickly. In the graph oda slope enna? Very good. இது V by R இருக்கும். So we can, V by I. The things which is happening in the y-axis, that is V, divided by x-axis, that is I. So this is basically, we know that R. அப்படினா எனக்கு ஒரு question இருக்குடா. Let us say I'm just plotting the graph for two materials A and B. Okay, so two materials da irukke and the two materials la I have just marked it. So in the graph path you have to tell me which one is having higher resistance. Which one, A or B, is having higher resistance? Okay, enna higher resistance? Tell me da. Which one is having higher resistance? A or B? Think well da. So இப்போ இந்த கிராஃப்ல x axisல என்ன போட்டுருக்கேன், y axisல என்ன போட்டுருக்கேன். Okay, yes, very good. B தான் higher resistance. ஏன்னா இது IV graph தான், not VI graph. So இதோட slope என்னடா? இதோட slope 1 by R தான். கரெக்ட்டா? So இப்போ the slope is less. Which one is having less slope? அதுக்கு தான் ஆக்சுவலா higher resistance இருக்கும். So நீங்க பாக்கும்போது slope of A is greater than that of slope B. Okay, so which means this is 1 by RA, this is 1 by RB. So அப்படினா என்னால சொல்ல முடியும் RA will be less than that of RB. Clear ஆ இருக்கா? So now let us say எனக்கு இன்னொரு graph இருக்கு. This is what another graph. இங்க வந்து C இருக்கு, D இருக்கு. In this case, which one is having higher resistance? In this case, which one is having higher resistance? கொஞ்சம் சொல்ல முடியுமாடா? Everybody, C or D, which one is having higher resistance? இந்த graph பார்த்து நீங்க வந்து சொல்லணும். Very good, very good. ஏன்னா வந்து இது வந்து VI graph தான். இதோட slope என்ன? இதோட slope வந்து 6 தான். அப்படின்னா which one is having higher slope? Slope of D is more than that of slope of C. அப்படின்னா என்னால வந்து சொல்ல முடியும். We can say that slope வந்து more இல்ல. அப்படின்னா the resistance of D will be more than that of C. Clear னா கொஞ்சம் red heart போட முடியுமாடா? Everybody, everybody. கொஞ்சம் red heart, red heart. And also don't forget to what? Like the session and also share with your friends as well. Okay? Right? Okay? So now, thank you, Ada. Thank you so much. Now we are going to discuss the limitations of Ohm's law. Limitations of Ohm's law. What is this limitations? Limitations, the first one is this is not valid in higher temperature. Okay, so we know that the graph should be like this. Correct? It should be a straight line. Ana வந்து higher temperature la வரும்போது it will be deviate from the graph. And also semiconductors எல்லாமே வந்து when we were just discussing about the diode characteristics. Okay, so diode characteristics according to Ohm's law, இப்போ வந்து ஒரு particular currentக்கு one value of potential மட்டும்தான் possible இருக்கு. ஆனா வந்து when it comes to semiconductors இந்த diode characteristics எல்லாமே வரும்போது one potentialக்கு வந்து what to say, I mean one potential ke different ana currents and also one current ke equivalent ana different ana potentials idellame vandu possible da. So right now these are the limitations when it comes to diodes, this transistors ellame varumbogudhu nama Ohm's law vandu valid alla. And we call some devices as ohmic devices. What is this ohmic devices? Very simple, the devices which obey Ohm's law. That is what ohmic devices. அப்படினா non ohmic devices கொஞ்சம் சொல்ல முடியுமாடா? Non ohmic devices கொஞ்சம் சொல்ல முடியுமா? What is non ohmic devices? Ohm's law valid அல்ல. இப்போ வந்து அந்த devices not obeying Ohm's law na we will call it as non ohmic devices. Clear இருக்கா? So this is the what to say sum of the what to say the sum of the limitations. Okay, and when it comes to conductors, this IV graph or let's say VI graph will be coming like this. Okay, for the conductors nama IV illana VI graph will be coming like this. But when it comes to semiconductors, the graph is not going to be, we said na idu vandu it is not valid. Okay, appadi solli irukella, this is not valid, Ohm's law is not valid. Ipo vandu Ohm's law valid na idu vandu straight line ah irukanum. Ana for semiconductors, if you are just plotting this, we will be getting a graph like this. Okay, we will be getting a graph like this. This is for the conductors. Conductors க்கு வந்து fine தான், இது வந்து obey பண்ணும். ஆனா வந்து when it comes to semiconductors, the graph is like this. Clear இருக்காடா? Everybody understood? Okay. So this is what the another thing which we should study in the case of ohmic and non-ohmic resistors. Okay, understood? Okay. So now we are going for, we understood about Ohm's law expression vanda we got it. So now we are again going to what to say update some of the equations. We know what is Ohm's law, V is equal to IR. Correct alla? So idu vanda actually idla vanda potential in nama what to say current, resistance ellame vanda scalar quantities da. ஆனா வந்து எனக்கு என்ன வேணும், we know that I want the vector form of Ohm's law. Okay, vector form of Ohm's law. So on the vector form சொல்லும்போது I will be get it as J which is equal to sigma E, or otherwise I can say that E divided by rho. இதுல வந்து sigma na என்ன, conductivity da. Okay, sigma na என்னடா, conductivity da. Okay, and rho என்ன, rho வந்து resistivity da. இதெல்லாமே வந்து material properties. Okay, these are all coming as material properties. So this is what the first set of equation. Okay, wow. This is what the first set of equation. Next, now I'm going to teach you nothing but the microscopic form of the Ohm's law. Okay, microscopic. Okay, microscopic form. Okay, so idhula one. Sorry, guys, 1 second. So, idhula vandu paakumbodhu, we will be get it as J is equal to NE square tau by M into E. So, this is what the microscopic form. So, I can say that according to this, the sigma will be coming as NE square tau by M. Correct? Everybody understood? Yes or no? Yes or no? So, this is what the equation we have. Appadina, what is going to be the expression for rho? What is the expression for rho? இப்போ வந்து sigma இப்படினா what will be the expression for rho? We know that sigma which is equal to 1 by rho da. அப்படினா rho will be coming as m divided by n e square tau it will come. Just this, what is it? You can just take the inverse of that. Okay, so this is what the another form of Ohm's law. You have to study all this equation and சொல்லிருக்கேன் இந்த equations base பண்ணி you have different types of questions expect பண்ணலாம். Okay, wow. So that is what I'm saying. Okay, that is what I'm saying. Please do study these equations and just give some kind of, yes, da, very good. Okay, so give some kind of extra time to revise the formulas as well. Okay, and guys, don't forget to like the session. And also, I just wanted to tell you one more thing. Okay, 1 second. So right now we know that we have our veterinary batch and also we have our lecture batch in the offline centers. இப்போ வந்து if you wanted to join the batch, description box ல link இருக்கு. அது மட்டும் இல்ல, let us say if you wanted to. Okay, so 1 second. So if you wanted to join our MVSAT, okay, அது வந்து வேதாந்து conduct பண்ற ஒரு what to say ஒரு exam scholarship test da. So idhula vandu if you got the good marks na, definitely you have a lots of things. So adukage enroll பண்றதுக்கு இங்க ஒரு link இருக்கு, நம்ம description box பார்த்தாலே தெரியும். So you can just click on this link and adukapra enna பண்ணலாம், you can just go for the dates எல்லாமே வந்து இங்க mention பண்ணிருக்கேன். So which are the dates possible? So here you can see this days we have the MVSAT is happening. So idhula vandu இதுதான் வந்து நம்ம registration. Okay, registration வந்து நீங்க வந்து you have to do it like this. So மறக்காம நீங்க வந்து register பண்ணனும். And also register பண்றதுக்கு you can just click it over here. You can give your details. Also your closest ஆன city வந்து you can just give. So அப்படியே you will be getting the informations regarding this MVSAT exam. So மறக்காம உங்களுக்கு வந்து join பண்ணலாம்டா, because this will definitely help you. Okay. Okay. For everybody it is there da. 7th I think 7th or 8th, I'm not sure. Okay, then from there you can just get it. Okay, so நீங்க வந்து இங்க பாக்கும்போது okay, so you have to give your registered mobile number. அதுக்கப்புறம் you will be getting an OTP. அதுக்கப்புறம் you can just continue with this. Clear? Okay, so this is what we need to study in the what in the Ohm's law part. Now I just wanted to talk about resistance. Okay, we wanted to talk about resistance. Resistance na வந்து சொல்லி இருக்கேன், இது வந்து ஒரு கான்ஸ்டன்ட் வேல்யூ தான். இப்போ வந்து if you are just talking about Ohm's law, V is proportional to I, and the proportionality we need to make it into equal. அதுக்கு தான் we are introducing this R. அப்படினா எனக்கு ஒரு question இருக்கு. Let us say right now the potential வந்து V தான், அதுக்கு corresponding ஆன current வந்து I தான், and resistance வந்து R தான். Okay, now I am making this V into 2V, which means I'm going to make it double. நம்ம voltage வந்து I'm going to make it double. அப்படினா what will happen to the resistance? What will be the value of resistance? அதுதான் வந்து எனக்கு தெரியும். Okay, what I said, so when voltage is V, இல்லனா potential difference is V, current வந்து I தான், அந்த டைம்ல resistance வந்து R தான். அப்படினா if I'm making the voltage into 2V, which means 2 times increase பண்ண போறோம். அப்படினா you tell me what will be the R value. Tell me. Simple question. Yes, very good, Abhinaya, very good. So actually that is what we have discussed, no? Okay, இப்போ வந்து இந்த V, okay, V and I. We know V is equal to I R da. அப்படினா V by I என்னடா? V by I என்ன? R da. Okay, so first case we know this is V by I. Now second case we know that V is proportional to, according to Ohm's law, V is proportional to I. இப்போ வந்து V வந்து double ஆச்சுனா நம்ம current is also going to become double. அப்படினா நான் வந்து substitute பண்ண போறோம். So what I will be getting? 2V divided by 2I. Again I will be getting V by I, which means R. Okay, நீங்க வந்து if you are just making into 4 times 4V, then current will also increase in the same ratio because it is proportional. அந்த டைம்ல கூட resistance கேட்டுட்டேனா it is same. Resistance வந்து R தான். It is not going to double, triple or nothing. Okay, resistance வந்து constant தான். ஆனா வந்து இந்த resistance will change. Okay, இந்த resistance will change some points. Can you just please let me know? What are the points when this resistance will change? Let us say the resistance will definitely definitely change if you are just changing the material. Okay, if you are changing the material, definitely in the resistance will change. Perfect. அதுக்கப்புறம் நீங்க வந்து பார்க்கும்போது இந்த resistance will change. Next point என்னன்னா, we know that, yes, very good, Hali. Length வந்து, okay, இப்போ வந்து என் conductor, okay, இது இப்படி தான் நம்ம resistor இருக்கு. இந்த resistor length increase பண்ணினா definitely resistance will also change. In the area of cross section change பண்ணிட்டேனா definitely resistance will change. Okay, so இப்படி there are lots of things. So அதனால I just wanted to make a relation for the resistance as well. Okay, so right now resistance is proportional to L and inversely proportional to A, and it is depending upon the material. So I can just keep a constant rho L by A. So this is what the resistance. This is what the resistance or the expression. Now I'm going to give you an example. Okay, I'm going to give you an example. Guys, don't forget to like the session, okay, and also share with your friends. மறக்காம channel subscribe பண்ணிக்கோ. Okay, so right now என்னாச்சு, நம்ம resistance வந்து rho into L by A தான். Correct அல்ல? So இப்போ வந்து எப்படி, what is happening? So basically வந்து resistance will increase when the number of collisions increases. சின்னதா I'm going to give an example. Let us say நம்ம வந்து ஒரு crowded ஆன roadல we are just walking. Okay, அப்படினா definitely என்ன ஆகும்? You will collide with many people. கரெக்டா? Collisions வந்து increase ஆகும். Let us say அந்த மாதிரி அந்த road வந்து 1 kilometer extend ஆச்சு. அந்த 1 kilometer கூட இந்த மாதிரி தான் crowd இருக்கு. அப்படினா என்ன ஆகும்? Number of collisions will increase. Number of collisions will increases. Now what will happen? Resistance will also increase. Clear? Understood? Hi Najifa. Yes. Okay. So now R depends on material only. Illada. R is not just depending upon material. I'll come to it. Okay. Okay. So now what we have mentioned, definitely number of collisions increases like this. Now again, in the road la suddenly we are just increasing the width. அப்படினா என்ன ஆகும்? Definitely the number of collisions, the number of people we are colliding with, அது வந்து reduce ஆகும்ல. Clear? So what we were discussing, when we were talking about the resistance, we can say that when we are walking on a crowded road, suddenly வந்து அந்த area increase ஆச்சுனா number of collisions will reduce. Number of collisions வந்து reduce ஆச்சுனா, okay, number of collisions வந்து reduce ஆச்சுனா அதோட மீனிங் என்னடா? அதோட மீனிங் என்ன? Resistance will also reduce. Clear இருக்கா? Everybody understood? Clear? Yes or no? Respond with your favorite heart, guys. Everybody except black. உங்களுக்கு புரியலனா மட்டும் தான் நீங்க வந்து black heart போடணும். Okay, rest of the colors எல்லாமே வந்து favorable colors. Okay, so now please let me know whether you understood how this varies. Okay, so basic-ஆ சொல்லும்போது, okay, நம்ம resistance இல்லனா number of collisions increase ஆச்சுனா, what will happen da? நம்ம resistance will also increase. When length increases, number of collisions will definitely increase. Hence resistance will also increase. That is why we are saying R is proportional to L. Now area increases, what will happen da? In the number of collisions will reduce. அப்படினா நம்ம resistance கூட reduce ஆகும். Correct illa? So right now we can say that the resistance is depending upon 4 factors. First one is material. Okay, நீங்க வந்து copper material you have taken some other material, gold, silver. If you are taking all this resistivity, which means அது வந்து material property தான். இது வந்து different ஆ இருக்கும். So material changes, obviously resistance will change. ஏனா வந்து resistivity is a material property தான். Okay va? And also length area. இது மட்டும் இல்ல, இந்த material, இந்த resistivity is depending upon temperature. Resistivity is depending upon temperature. So we can say that the resistance is depending upon 4 factors. Can you please let me know the four things which is in the resistance ones depending upon 4 things? Can you please mention in the chat box? First one the length, area, material and the temperature. Clear arkada? Can you please respond everybody? So this is what the thing which we should study in the case of resistance. So அப்படினா material change ஆச்சுனா we have discussed all those things ma'am. அப்படினா எனக்கு வந்து temperature dependence. Okay, எனக்கு வந்து என்ன தெரியணும்? Temperature dependence வந்து கொஞ்சம் clarity வேணும் ma'am. Okay, so அதுக்காக we are going to one thing. I'm just considering the conductors. Okay, first I'm going to consider the conductors. Okay va everybody? Okay, so in the case I'm going to use this equation. Resistivity which is equal to m by n e square tau. Okay, இப்போ வந்து ஒரு conductor if you are considering na, if you are considering the conductor, m value வந்து it is not going to vary. Number of electrons, number of charge carriers, that is also not going to change. E value இது வந்து constant தான். அப்படினா என்னால சொல்ல முடியும், this resistivity is depending upon, it is inversely proportional to என்னடா நம்ம relaxation time தான். Clear ஆ இருக்கா? Everybody understood? So first of all, conductors choose பண்ணும்போது அதுல என்ன இருக்குடா? It is actually inversely proportional to 1 by, or let's say inversely proportional to the relaxation time. So அப்படினா நான் வந்து கொஞ்சம் இந்த relaxation time வந்து focus பண்ண போறோம். So let us say இப்போ வந்து I'm giving the temperature. Okay, temperature na enna? I'm giving the thermal energy basically. இந்த thermal energy நம்ம electrons எல்லாமே வந்து utilize பண்ணும். Which means அதோட kinetic energy வந்து it will increase. For example, நீங்க வந்து you are just simply sitting. உங்களுக்கு வந்து எனர்ஜியே இல்ல. Okay, you don't have any energy. Okay, you are just completely dead. Okay, so அந்த டைம்ல தான் உங்க sibling is coming and trying to provoke you. Okay, அந்த டைம்ல நீங்க வந்து okay, ignore அப்படிதான் இருக்கும். கரெக்ட் இல்ல? ஆனா வந்து let us say நீங்க வந்து ஃபுட் எல்லாம் சாப்பிட்டு you are just being very what to say டா, அந்த ஒரு full on எனர்ஜில தான் இருக்கு. அப்படினா என்ன ஆகும்? அந்த fight will happen in a fraction of second இல்ல? So அந்த மாதிரி தான் எலக்ட்ரான்ஸ்க்கு right now எனர்ஜி இல்ல. Okay, now what we are giving temperature. இந்த டெம்பரேச்சர்னால definitely நம்ம kinetic energy of the electrons will increase. அப்படினா இனிஷியலா வந்து இப்படி தான் collisions were happening. ஆனா kinetic energy increase ஆச்சுல்ல, அப்படினா நம்ம collisions will be இன்னும் quick-ஆ it will happen. Okay, so number of collisions இல்லனா நம்ம collision ஓட இந்த relaxation time tau will reduce quick-ஆ. நம்ம average time between the collisions will come to very small value. Okay, varsha right illada? Varsha if I'm not wrong. Okay, so now we can say that இப்போ வந்து resistivity is inversely proportional to tau da. When the temperature increases, in the relaxation time decreases. Okay, அப்படினா சொல்லுடா, what will happen to resistivity? Can you please let me know? ஆமாடா, flag color. Okay, yes. Again, I don't know right now, I'm just choosing these 3 colors only. Okay, so tell me da, இப்போ வந்து நம்ம relaxation time வந்து decrease ஆச்சுனா, inverse relation இல்ல, so the denominatorல இருக்கிற value reduce ஆச்சுனா நம்ம result வந்து it will increase. So we can say that the resistivity will increase. Clear ஆ இருக்காடா? Can you please let me know everybody? கொஞ்சம் can you just respond? everybody இந்த temperature dependence வந்து clear-ஆ இருக்கா? Okay, perfect. அப்படினா நான் வந்து I'm going to talk about semiconductors. Okay, நான் வந்து I'm going to talk about semiconductors. இந்த semiconductorல என்ன ஆச்சு? Semiconductorல again I'm using the same equation. Rho which is equal to m divided by n e square tau. Okay வா? Rho which is equal to m divided by n e square tau. So இதுல வந்து பார்த்தேனா semiconductor consider பண்ணும்போது again m and e square வந்து almost constant values. அதுல வந்து ஏதோ variation எதுவும் இல்ல. Okay, and semiconductor நால என்னன்னா நம்ம number of charge carriers தான். Okay, and t in a relaxation time. So the thing is like, yes, smash the like button. Yes, Varsha. Okay, so right now relaxation time. So நம்ம conductors compare பண்ணும்போது இதுல வந்து the number of charge carriers ஓட amount வந்து less தான். அப்படினா relaxation time இந்த temperatureனால relaxation timeல அவ்ளோ changes இருந்தாலும் it won't affect the resistivity. ஏனா வந்து 1000 number of electrons இருக்கு, இங்க வந்து 10 number of electrons தான் இருக்கு. So அங்க வந்து even relaxation time வந்து increase ஆனாலும் decrease ஆனாலும் effectiveness சொல்லும்போது கொஞ்சம் it's not there. அதனால அந்த relaxation time ஓட contribution வந்து negligible தான். அப்படினா what is resistivity is proportional to what right now? Resistivity is proportional to 1 by n தான். ஏனா m, e square and tau we are considering it as was almost வந்து not varying quantities the I mean constant அது வந்து it will maintain. அப்படினா right now we have என்னடா number of charge carriers மட்டும் தான் இருக்கு. So now I'm just asking you, temperature increase ஆச்சுனா, okay, temperature increase ஆச்சுனா what will happen? What I'm asking, temperature increase ஆச்சுனா what will happen? Of course we know that temperature increase ஆச்சுனா covalent bond will break, number of holes and free electrons will increase. Clear அல்ல? So right now we can say that when temperature increases, we can say that the number of charge carriers will increase in the case of semiconductors. Okay, will increase in the case of semiconductors, and we know the relation rho is proportional to 1 by n. அப்படினா n increase ஆச்சுனா what will happen to rho? What will happen to resistivity? Of course இது வந்து increase ஆச்சுனா inverse relation, so it will reduce. So conductorsல resistivity was proportional to or let's say அங்க வந்து பாக்கும்போது நம்ம temperature increase ஆச்சுனா அங்க வந்து resistivity கூட increase ஆகும். ஆனா இங்க வரும்போது what happened? When temperature increases, resistivity is actually reducing. Clear ஆ இருக்கா? Everybody understood? So if you wanted to represent in a graph the resistivity, or you can represent it as resistance with the temperature, it will be coming like this. It will reduce with the time. Okay, it will reduce with the time. Clear arika? Everybody, can you just please respond with a green heart quickly? Everybody. Everybody with a green heart respond பண்ணுடா. So இப்போ வந்து மேம் எனக்கு வந்து இதோட behind இருக்கிற theory எல்லாமே வந்து clear-ஆ புரிஞ்சிருச்சு மேம். Now I want another thing. Now I want an equation for this. Okay, எனக்கு வந்து resistivity இல்லனா resistance, temperature depend பண்ணி இருக்கிற ஒரு equation எனக்கு வேணும். அப்படினா உனக்கு வந்து you can just write this equation R which is equal to R naught into 1 plus alpha delta T. இல்ல resistivity-யா உங்களுக்கு தேவையா இருக்கா? So resistivity rho naught 1 plus alpha delta T. So இதுல வந்து R naught என்னன்னா R naught இல்லனா rho naught என்னன்னா it is nothing but the resistance at the initial stage. Okay, initial stage. Maybe அது வந்து 0 degreeல நீங்க வந்து calculate பண்ணலாம் இல்லனா 60 degreeல. So 60 degreeல உங்களுக்கு வந்து resistance தெரியும். அப்படினா if you are just increasing the temperature to 100 degrees Celsius, what will be the resistance? அதுதான் வந்து question. அப்படினா R naught என்ன 60 degree டெம்பரேச்சர்ல இருக்கிற ரெசிஸ்டன்ஸ் தான். ஓகே, and next வந்து alpha. இது வந்து temperature coefficient. Okay, இது வந்து என்னடா temperature coefficient. இது வந்து positive. Okay, this will be positive for metals. And this will be negative for semiconductors and for insulators. In insulators, it will be almost equal to 0. Okay, va? And what is delta T? What is delta T? Which is nothing but the temperature difference. This is nothing but the temperature difference. So this is what the equation connecting all these things. Clear? Everybody, can you just respond? Can you just respond? Yes, clear. Okay. So right now I'm going to give some other relation. For example, let us say right now நமக்கு வந்து ஒரு resistor இருக்கு. அந்த resistorக்கு வந்து length வந்து L தான். Now what I'm going to do? I am going to increase the length. Some 2 times, இல்லனா 3 times, 4 times. அப்படினா how will be the equation is going to be. So that is what I'm going to tell. So let us say நம்ம initially இருக்கிற resistance வந்து R1 தான். Okay, when it had a length L1. Okay, divided by R2, which means the new resistance. This will be coming as L1 square divided by L2 square. So if you wanted to find R2, what you can do? R1 into L2 square divided by L1 square. Clear? இப்போ வந்து let us say the relation is given. L2 na let us say 3 times L1 தான். Okay va? What is L2? L2, which means initially இருக்கிற length na L1 தான். ஆனா நான் வந்து என்ன பண்ணிருக்கேன்? இப்போ வந்து I'm increasing the length to 3 times. அப்படினா I will be just substitute here. Let us say R2 இல்லனா நம்ம new resistance will be coming as R1. அதுல எதுவும் change இல்ல. So L2 square னா என்ன சொல்லிருக்கேன்? 3L1 square divided by L1 square. அப்படினா L1 square will go and we will be having 3 square left. So அப்படினா என்னால சொல்ல முடியும், if you know how many times it is increased, okay, maybe 3 times ஆ இருக்கலாம், 5 times ஆ இருக்கலாம், அப்படினா the new resistance will be coming as n square. எவ்வளோ times you have multiplied or let's say increase the length, அதோட square into the initial resistance. Clear ஆ இருக்கா? So this is what the first relation. Okay, so if you know the length, initial length, and finally you are just increasing twice, thrice or n times, அப்படினா the new resistance you can find it as n square into the old resistance. Clear ஆ இருக்காடா? So next வந்து you have changed the radius. Okay, what you have changed? You have changed the radius. So initially இருக்கிற resistance வந்து R1 தான். And right now we need to find R2. So this will be coming as R2 raised to 4 divided by R1 raised to 4. Okay, power will be 4 times. Clear? Okay, so right now let us say you know that R2 which is equal to 2 times R1. Okay, number radius we have increased to. We have increased to what? 2 times than the initial. அப்படினா again you will substitute, instead of R2 you will substitute it as 2 raised to 4 into R1 raised to 4 divided by R1 raised to 4. So this will be get cancelled. So it will become just as n to the power 4. எவ்வளோ times நீங்க வந்து multiply பண்ணிருக்கே, that you will be substitute here. Okay, so the new resistance will be, நம்ம R2 value என்ன ஆகும்டா, இந்த n to the power 4 will be coming over this side. R2 will go to that side. So initial resistance divided by n to the power 4 will be the answer of this part. Clear ஆ இருக்கா? Clear ஆ இருக்காடா? Please let me know. Please respond with your favorite heart. இல்லனா எப்படிடா? R na radius da. Radius வந்து change ஆக்கி, we have just made change in the radius. Previously we changed the length. Clear? Yes. Abhinaya black heart ada puriyalaya? Please let me know. Yes, Pradeep. Radius, bro. Hallie. Clear? Anybody, can you just respond? Then we can just move on to the area part. Because ena vandu idu related up, you might have seen many questions, correct? Okay, no ma'am, favorite. Okay, I was thought like black heart illa. Okay, abhinayku vandu she couldn't understand. Okay, yes da Pratibha ask. Okay, so now we are going for ipo vandu area of the wire vandu change ஆச்சு. அப்படினா what will happen? R1 area change ஆச்சு. R1 divided by R2, which is equal to A2 square divided by A1 square, it will come. So again, இப்போ வந்து A2 will be like 5 times than the A2, I mean A1. அப்படினா அது வந்து substitute பண்ணலாம் and you can just find R2. Clear இருக்கா? Okay, guys, don't forget to like the session. I can see many of you are not liking the session and you guys know which I don't like at all. Correct alla? Yes or no? In the two cases எது எல்லாம் constant ன்னு மட்டும் சொல்றீங்களா? Constant ஆ? இதுல எதுவும் constant இல்லடா. We are not talking about constant thing. Let us say initially and resistor ஓட length வந்து L தான். நான் வந்து இப்போ என்ன பண்ணிருக்கேன்? I was just made to 2 times length. அப்படினா new resistance, definitely length change ஆச்சுனா நம்ம வந்து study பண்ணிருக்கேன் இல்லடா, resistance will also change. கரெக்ட்டா? Clear இருக்கா? Okay, so அதுதான் வந்து சொல்றது. இதுல வந்து there is no constants and something. Initially இருக்கிற resistance தெரியும் and now how many times the length or radius or area வந்து increase ஆச்சு இல்ல decrease ஆச்சு அதோட value கூட நமக்கு தெரியும். அப்படினா how will be the relation comes? R1 னா initially இருக்கிற resistance, R2 னா நம்ம new resistance in all cases. Okay, இப்போ வந்து L1, A1, R1 னா I mean small R1 னா அது வந்து initially இருக்கிற length தான். Okay, and small letter R2, A2 and L2 na after increasing or decreasing, what is the current length, current area, current radius tha. Clear arika? Okay, so now again coming back to the resistance, R which is equal to, we know, rho into L by A. So ipo vandu na enna panna porona, I'm just going to rewrite this in different formats. Okay, so first of all I'm going to write rho which is equal to density. Okay, so rho I'm not writing. Okay, let me just write it as D. Illana in the resistivity and density vandu confuse agum. D na ennada? D na enna? Density. So density oda equation konjam solla mudiyumada? What is density oda equation? Density oda equation. Density oda equation na mass by volume. Appadina volume I can, again you can just write it as volume as area into length. Correct illa? இப்போ வந்து எனக்கு ஏரியா தெரியல, क्वेश्चनல ஏரியா they didn't give, ஆனா வந்து density given, mass given. அப்படினா what I can do, I'll be just find area. Area na enna? What is going to be area? Can you please let me know in the chat box everybody? What will be the expression for area? It will be m divided by dl, it will come. So அப்படினா நான் என்ன பண்ண போறேன்டா, I will be in the rho na resistivity not density. L divided by what will happen? I can just go for m by dl. Okay, and the d na enna, and the small d na ennada? D vanda nothing but namma what is it, density da. Clear arika everybody? So now you can just substitute. Okay, in the area instead of area ungalku vanda in the value substitute pannalam. Okay, done. Okay, so now another case, let us say ungalku vanda length theriyala. அப்படினா இதுல இருந்து you will be finding the expression for length. What will be the expression for length? It will be coming as m divided by a into d. So you can just substitute that as well. Clear arika everybody? So இந்த மாதிரி different ஆன expressionsல you can just go for the you can just find the what, the resistance part. Okay, clear everybody? So ipo vandu you can just substitute in the value vandu substitute pannalam. So what is resistance illa? R which is equal to rho inge irukke, and what is the L value? M divided by A into D da, divided by innoru A irukku. So you will be basically getting rho M divided by A square D, it will come. So you can just find, okay, whatever be the way you have different methods, you have different ways to find this answers. Clear everybody? Okay, so konjam questions pannalama, ready na konjam fire podlamada? Everybody, you can just put some fire. Okay, perfect, perfect. So now we are going for our first question. First question. Yes, here we have the first question. You can just give me the answer option A, B, C, D and all. Yes. Quick, you can respond, guys. இது வந்து காப்பர்னா மெட்டல் தான். Okay, so resistivity is decreasing with temperature in metal. That is what we have studied. No illa. Okay, proportional relation dana. First option, those who are saying option A la enna resistivity decreases with temperature in conductors. Adu vandu wrong illa. Appadina what will be the answer? We will be having, yes, very good Abhinaya, option B will be the right answer. Resistivity is proportional to temperature da, so resistivity increases with the temperature. Now let us go for the next question. Yes, so now you can just do this question. Guys, don't forget to like the session. You can give your answers. I'm waiting for your answers. So right now, let us just see that. So we know that I, which is equal to NEAVD. So இப்போ வந்து பார்க்கும்போது J is equal to இந்த A, if I'm taking na, I will be getting this equation. Correct alla? Okay. So right now, one second. Okay. So right now, yes, the option D will be the right answer. Okay. So now we know this. And what is J? J in a I by A da. So this will be coming as this. So right now, I, N, E, idellame vandu constant na. Can I say that the drift velocity will be proportional to 1 by A? Appadina, என்ன ஆச்சுடா பிரதீப்? Yes, very good Abhinaya, very good, very good. அப்படினா V1 by V2 will be equal to A2 by A1, inverse relation. So now it is given that let us say the diameter சொல்லும்போது நம்ம area இல்ல. So area வந்து it will be nothing but pi r square தான். Okay, pi r square தான். So நம்ம ratio வந்து diameters ஓட ratio வந்து 2:1 தான். Then we can say that when we are just squaring, I mean whether it is you are taking what is a diameter or radius, the ratio will be same only, because ena vanda let us say d1 by d2, okay, which will be coming as 2r1 divided by 2r2 le. So if you are taking the ratio, whether you are taking for diameter or radius, it will be same. So idu vanda square da we are taking, so I can say that this will be 1 by 4. 1 by 2 the whole square it will come, since it is proportional to r square, area is proportional to r square. So we can say that we will be getting option D 1:4. Clear arka? Clear arka? No ma'am, onnu illa, correct ada. Okay, fine. Understood ada? Please let me know with your favorite heart. With your favorite heart, guys. I'm just waiting for your favorite heart. Yes, ma'am, wait பண்ணிட்டேன். Okay, so now perfect. அப்படினா we are going for the next question. இது வந்து again similar ஆன ஒரு question தான். So you guys will definitely give me the right answer now. So waiting for your answers, guys. Guys, don't forget to like the session. Okay, again same relation தான் நம்ம வந்து யூஸ் பண்ண போறோம். Hey, konjam you have to think da. Likes and also மறக்காம subscribe பண்ணுடா. Yes, right answers எல்லாமே வருது. So yes, whatever you have said is correct. So again we will be going for VD is proportional to 1 by area. In the relation da choose பண்ண போறோம். Okay வா? So right now current is flowing in the wire with a diameter D having a drift velocity VD. Okay va? So and the drift velocity, whenever we are just taking for the drift velocity, so let us say V1 by V2, we know that this will be coming as diameter oda square. This is how the relation will come. So initially vanda nama drift velocity, nama diameter vanda D da, so it will be coming as D square. Now what will happen? We have made the diameter into D by 4, so D square by 16 it will come, which is equal to what was the initial drift velocity is VD divided by V dash. Now the question is, you have to find this V dash. Correct? We have to find the V dash. So now what will happen in the D square will be get cancelled. So in the side la 1 by 16 I will get, and VD by V dash. Now I'm taking this V dash over here. So when I'm taking V dash on the left hand side, 16 I will be taking on the right hand side. So I'm going to get V dash, which is equal to 16 VD. So I'm going to get option C as the right answer. Clear arka? Everybody, please let me know. Clear na konjam green heart poduda. Perfect. Appadina, we are going for the next question. So in the question panla. மறக்காம லைக் போடுடா. ஸோ இது வந்து டைரக்டா சப்ஸ்டியூட் பண்ணலாம். இதோட ரிலேஷன் வந்து ஆல்ரெடி நம்ம வந்து ஸ்டடி பண்ணியிருக்கேன். R1 by R2 will be coming as L1 square divided by L2 square. அப்படின்னா what will be the answer? Yes. Most of you guys are giving the right answer. So let us say what is the thing we have a metal wire of circular cross section has a resistance of R. The wire is now stretched without breaking. The length is double. So we have this equation R1 by R2 which is equal to L1 square by L2 square. So idla vandu paathena L1 square divided by L2 na enada 2 times L1 square. So அப்படினா we will be getting R1 by R2 which is equal to 1 by 4. So இதுல வந்து என்ன we have to find R2 by R1. So you can just go for the inverse of it 4 by 1. So we will be get it as option C as the answer. Clear arika? Guys, don't forget to like the session. Everybody. So now we are going for one more question. அதுக்கப்புறம் இன்னொரு break போலாம். அதுக்கப்புறம் we can just continue with the series and parallel circuits. So now this is your question. Perfect. அது வந்து கரெக்டா இருக்கு அபிநயா. நீங்க வந்து கொஞ்சம் you go back and you have to do it da. So quicker you can do it da. What will be the answer for this question? Getting the right answers. Very good. So right now இதுல வந்து என்ன கொடுத்திருக்கேன், mass of 3 wires of copper are in the ratio. Okay, so m1 is to m2 is to m3, which is coming as 1 is to 3 is to 5. Correct? And their length is having a ratio. L1 is to L2 is to L3 is having a ratio. What is that? 5 is to 3 is to 1. What do you need to find? The electrical resistance. So இப்போ வந்து resistance நீங்க வந்து in terms of mass and length you have to write. So அதுக்காக என்ன பண்ணலாம்? First I'm going to start with again density. Okay, density na என்னடா? Mass by volume. So mass by area into length. அப்படினா I could just write it as mass will be density into area into length. இது வரைக்கும் clear ஆடா? Can you please let me know? Till this it is clear. Density into area into length. அப்படினா இதுல வந்து 3 wires வந்து same material da. So can I say that density for both the 3 materials will be same? Can I say that? அப்படினா எனக்கு வந்து சொல்ல முடியும்ல, m is proportional to area into length. Can I say this? கொஞ்சம் red heart போட்டு can you just respond? Everybody? Okay, so now நீங்க வந்து பாக்கும்போது you can see that நம்ம questionல mass இருக்கு, length இருக்கு, area தான் இல்ல. Okay, so right now I'm just writing m by l is proportional to area, which means wherever we have this area அங்க வந்து we can just substitute m by l. Clear ஆ இருக்கா? Okay, so we know that density வந்து same for the whole all the 3 materials. ஏன்னா 3 materials வந்து copper தான். Okay va? So right now the thing is like I found that this area is proportional to mass by L. ஏன்னா வந்து I have written in terms of mass and length because area வந்து clear it is not given. So அப்படினா resistance find பண்ணும்போது I know that this is proportional to L by A தான். So right now எனக்கு தெரியும் இந்த area na என்னடா? Area na என்ன? Mass by L தான். So this will be coming as L square by M. Clear ஆ இருக்கா? So wherever we have area, anga vandu I'm just using this m by L and I will be getting the resistance which is proportional to L square by M. So ipo vandu enna pannanum? I wanted to find R1 is to R2 is to R3 na I can go for L1 square by M1 is to L2 square by M2 is to L3 square divided by M3. இதுல வந்து L1, L2, L3 அது வந்து it is given. So அப்படினா I'm just going to write 5 square and 3 square 1 square. Okay, divided by mass. This is 1 divided by 3 divided by 5. So இப்போ வந்து you have to make it the denominator same to get the final answer. And while we are doing, you will be getting option D as the right answer. Clear Arkada? Everybody, can you please let me know with the pink heart, pinky heart? Everybody? Crystal clear. Okay. Yes, da. Nama we are going for the break only. So, for the time ennachu 7:30. Okay, so we can just come back by 7:50. Okay, and nama targets for like okay, so see you guys after some time and bye bye. Hello, 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 everybody. Are you guys here? If you're here, please put some fire in the chat box, guys. Hello, 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 everybody. Are you guys here? So, yes, am I audible, visible? Start panlama. Yes, Ali, Abhinaya, very good, very good, very good. So please let me know, guys. Are you guys available in the chat box? Yes or no? Perfect. Okay. So right now we are going for resistors and we got it, and we know Ohm's law as well. Now we are going for the parallel and series connection. So idhula vandu neriya complicated ana series parallel circuits irukku. So right now we will do some questions and some of those scenarios, and definitely detail la ungalku theriyunumna I will be in the Thursday class. Thursday vandu I'm going to put a video how to solve the circuits easily. So அதுக்கு வந்து ஒரு இன்னொரு ட்ரிக் இருக்கு. அந்த ட்ரிக் தான் நான் வந்து அந்த வீடியோல சொல்ல போறேன். அந்த ட்ரிக் உங்களுக்கு கரெக்ட்டா if you got it na. So I hope last day நான் வந்து I have done for pulley block system as well. Okay. So those who have watched அவங்களுக்கு வந்து clarity கிடைச்சிருக்கும். Okay. How to do the pulley block problem. So if you have not even see that, you can just do one thing. You can just check it in the video section. Okay. Video section la like in the first I mean recent ada I have put it there. Like last 8-10 days illa. So you can just check it in the videos part la ungalku vandu check pannalam. So you will be get to know pulley block system eppadi easy ah solve pannalam. And the oru trick if you know na easy problems ellame vandu pulley block problems ellame vandu easy da. And if you want I mean if you wanted to study more about series parallel connection adu vandu eppadi identify pannum adu vandu theriyalana again Thursday vandu I'm going to put a video, and the video paathu you can just understand. Clear ah? Ready ah? So now we are going for it. Yes, we have Helen here. Hi, Helen. Yes, Lakshya, right? Yes. And Saravanan, very good, very good, very good. Okay. So now we are going for the series connection. இப்போ வந்து எனக்கு என்ன இருக்கு? I have 3 resistors in the series connection. Series connection என்ன? You are starting from one end of the resistor. Okay. So till you get some other connection, okay, or other junction. So இப்போ வந்து smooth without any junction எனக்கு வந்து இது I can just continue la. So I can say that in the 3 resistors வந்து என்னடா இதெல்லாமே வந்து actually seriesல தான் இருக்கு. Correct? Yes, Daratika. Hi. Okay. So right now, if I wanted to find the equivalent resistance, I can go for R1 plus R2 plus R3. This is what the thing. Let us say I have identical resistors. Okay. எனக்கு வந்து என்ன இருக்கு? Identical resistors தான் இருக்கு. அப்படினா R equivalent will come as n identical resistors இருக்குனா what is R equivalent? Very good Abhinaya. இது வந்து n into R தான். Okay, and series circuit la current across all the resistors வந்து same தான், ஆனா வந்து potential will be different தான். Clear இருக்கா? Potential வந்து different தான். So now let us say எனக்கு வந்து என்ன தெரியணும்? I wanted to know இந்த R1 across இருக்கிற potential எனக்கு தெரியணும்னா, okay, R1 across இருக்கிற potential, let me just call it as V1. Okay, in the V1 if I wanted to find now what I'm supposed to do, I can just go for V1 which is equal to R1 divided by R1 plus R2 plus R3 into the potential of the battery. Okay, if I wanted to find V2, okay, V2 na enna R2 across இருக்கிற potential தான். அப்படினா what will be the equation? Tell me. இப்போ வந்து எனக்கு வந்து R2 across இருக்கிற potential தான் தெரியணும். அப்படினா I can just do it as R2 divided by R1 plus R2 plus R3 into V. If I wanted to find V3, then I should go for R3 divided by R1 plus R2 plus R3 பண்ணலாம் into V பண்ணலாம், then I will be getting the value. And also This is, let us say, இது வந்து V2 we have mentioned, இது வந்து V3. So right now the total potential provided V, which will be equal to V1 plus V2 plus V3 தான். Correct அல்ல? Everybody understood. இப்போ வந்து எனக்கு வந்து if I wanted to find the current flowing through the circuit, okay, current flowing through the circuit, I know that the current will be everywhere, it is going to be I only. அப்படினா what will be the equation? If I wanted to find the current through the series circuit, I can go for V by R equivalent, which means V divided by R1 plus R2 plus R3 பண்ணிட்டேனா I will be getting the current ஓட equation as well. Okay? நான் சொல்லிருக்கேன்ல, இப்போ வந்து recent I am just taking these three colors only. இந்த three colors looks better in the what is a screen. அதனால தான். Clear ஆ everybody understood? Please let me know. அப்படினா quick-ஆ வந்து we can just go for the parallel combination. Ready-யா? Ready-na கொஞ்சம் இந்த white heart போடலாமாடா? White heart. Yes, perfect. Yes. So அப்படினா we are going for the parallel connection. So let us say எனக்கு வந்து I have two resistors like this. So now this is connected with the battery over here. This is what R1 and this is what R2. Correct? So இப்போ வந்து some current will flow from here and it will reaches up to here. ஆனா வந்து we know that this will be splitted as I1 and I2. Correct? So இப்போ வந்து I wanted to find the R equivalent na, for a parallel combination I should go for 1 by R1 plus 1 by R2 plus இப்போ வந்து if there are more resistors I can go for etc. Let us say இப்போ வந்து two resistors மட்டும் தானே இருக்கு. அப்படினா R equivalent you can do it as R1 R2 divided by R1 plus R2 பண்ணலாம். And now n identical resistors irundiruchuna, can you please let me know what is R equivalent? Can you please let me know? N identical resistors with the resistance R. What will be the equivalent resistance? Tell me. Hey, Hallie. R by N da vanda equivalent resistance. Clear arika? Everybody. And if you wanted to find, எனக்கு வந்து இந்த I1 தெரியணும். Okay, what is the current which is flowing through the R1 resistance? Okay, R1 resistor. அது வந்து தெரியணும்னா what should I do? I know what is V. V divided by R1 பண்ணலாம். If I wanted to find I2, then I can go for V divided by R2 பண்ணலாம். Okay, and in the parallel connection la V will be same across each of the resistor and I will be different across each of the resistors. Clear ada? கொஞ்சம் சொல்ல முடியுமா with the blue heart? Everybody, blue heart illa purple heart? And guys, don't forget to like the session. Everybody like the session மறக்காம. Okay, yes, perfect. அப்படினா we are going to do the first question. Okay, we are going to do the first question. First question எங்க இருக்கு? Okay, இந்த question பண்ணலாம். Okay, you can read the question and you can understand how to do it. அதுக்கப்புறம் you can give me the answer, then we can just do it together. Okay? ஆமாடா பிரதீப், முடிஞ்சிட்டேன். We have studied series and parallel connection. இப்போ வந்து question practice time. Yes, many of you are giving the right answer. Very good, very good, very good. Yes, yes, very good, very good. So, அப்படியே பார்க்கலாம்டா, what is happening here? இப்போ வந்து 3 resistors தான் இருக்கு, 5 ohm தான் each of the 2 resistor and one is 6 ohm. And on the point, S is dividing the 6 ohm resistor into 2. அப்படினா நம்ம equivalent resistance எப்படி இருக்கும்டா? This is what the 3 ohm and this is what the another 3 ohm, which means it is splitted into 2. இங்க இருந்து தான் நம்ம S, okay? And here we have 5 ohm and here again we have 5 ohm. And this is what the P as well. So this is what the circuit we have. Now if you are just checking on 5 and 3, okay, இப்போ வந்து let us say 5 ஓட 1 end ல இருந்து நீங்க வந்து ஸ்டார்ட் பண்ணிருக்கீங்க, okay, 5 ஓட 1 end ல இருந்து ஸ்டார்ட் பண்ணிருக்கீங்க without any, இங்க வரைக்கும் there is no junction, okay, இங்க வரைக்கும் when I'm just drawing எனக்கு வந்து confusion இல்ல. ஆனா right now I am having confusion, okay, either I should go for this route or this route. அப்படினா எனக்கு வந்து I understood இது வரைக்கும் it is actually series circuit தான். Seriesனா சிம்பிளா உங்களுக்கு வந்து என்ன பண்ணலாம், you can just add this to resistors. So what will be the equivalent resistance? Can you please let me know? What is going to be the equivalent resistance? This will be coming as 5 plus 3, it will be coming as 8, correct? And here also same thing will happen, smooth-ஆ இங்க வரைக்கும் you can just go. So this is again 8. இப்போ வந்து என்னாச்சு, 2 equal resistors, கரெக்டா? 2 equal resistors which is parallel. அப்படினா இந்த சர்க்யூட்டோட equivalent resistance using the equation R by N I can do it. N னா இங்க வந்து N ஓட வேல்யூ என்ன? The number of resistors என்னடா? It is actually 2 தான். So right now I'll be getting R by 2. What is the value of R? It is actually 8 தான். So 8 by 2 it will be coming as 4 ohm. Clear-ஆ இருக்கா? Clear-னா கொஞ்சம் green heart போட முடியுமாடா? Everybody put some green heart quick-ஆ. அப்படினா we are going for the next question. I hope everybody is excited. Perfect. So அப்படினா இந்த question பண்ணலாம். You can do it. I will help you after this. So just try to do it. And those who are watching, மறக்காம like பண்ணிக்கோ, also subscribe the channel as well. Check your answers again. So இதுல வந்து equivalent resistance தான் find பண்ணணும். Answers are changing. Okay. So பரவாயில்லடா, let us just do it. So இதுக்கு வந்து நான் சிம்பிளா I'm going to tell you some tips. Okay? So இங்க வந்து potential I'm taking it as VA. Okay? நம்ம இந்த பாயிண்ட்ல இருக்கிற potential வந்து VA தான். Okay? and in the point I'm just marking it as, let us say, V1. Okay, in the point என்னடா potential V1. அப்படினா இங்க இருந்தா I'm just keeping one line over here இல்லையா? So அப்படினா இந்த point what will be the potential? All the above. Okay, so tell me, இது வந்து V1 னா I'm just connecting with a line to this point. அப்படினா இந்த pointல இருக்கிற potential என்ன? That will also come as V1. அப்படினா I'm going for this point. I'm just marking the potential as V2. ஏனா வந்து definitely in between the two resistors இல்ல. So இந்த two resistors குள்ள இருக்கிற ஒரு பாயிண்ட்னால அங்க வந்து potential different இருக்கும். So I'm just marking it as V2. அப்படினா tell me டா, இந்த பாயிண்ட்ல potential என்ன? இந்த பாயிண்ட்ல potential என்ன? இந்த பாயிண்ட்ல இருக்கிற potential கூட V2 தான். Helen, we will be covering current electricity. இன்னைக்கு வந்து I think we will finish current electricity. அதுக்கப்புறம் பார்த்தேன்னா we will be having on Friday we will be having electrostatics. Next weekல தான் moving charges இருக்கும். Okay, clear? Done. Yes, perfect. So அப்படினா நான் வந்து I'm going to draw these what is it, resistors individually. Okay, so இந்த பாயிண்ட்ல இருக்கிற potential கூட I'm marking it as VB. Let it be. Okay, so now நான் என்ன பண்ண போறேன், I'm going to give names for all the vector, all the resistors. Let us say இதுதான் வந்து நம்ம first resistor, second resistor, third resistor, fourth resistor and the fifth resistor. Clear இல்ல? Now நீங்க வந்து என்ன பண்ணணும்னா, you have to tell me ஒவ்வொரு ரெசிஸ்டர்ஸ்க்கும் across இருக்கிற potential ஓட difference நீங்க வந்து சொல்லணும். இப்போ வந்து first resistor சொல்லிட்டேன்னா நீங்க வந்து சொல்லணும், okay, A and 1 ma'am, potential வந்து VA and VB. So simple உங்களுக்கு வந்து டைப் பண்றதுக்கு ஈஸியா இருக்கும். You can just simply go for A and 1. Okay, so then I will just mark it here. Now you people have to tell me for R2 what is the potential at the ends. Tell me everybody. So இது வந்து VA and V1. Next வந்து நம்ம R2, sorry, நம்ம resistor, second resistor. அதோட ends-ல இருக்கிற potentials ஓட values என்ன? So இதுதான் வந்து நம்ம, this is what our first one, this is what our second one. இங்க one side வந்து V1 தான், other side வந்து V2 தான். So I'm just marking one side is V1, another side is V2. Clear ஆடா? Everybody understood? Yes, V1 and V2 தான். Now I'm taking the third resistor. So immediate சொல்லடா, third resistor ஓட endல இருக்கிற values என்ன? One is V1, another one is V2. So நான் வந்து V1 இங்க mark பண்ணிருக்கேன், V2 வந்து இங்க mark பண்ணிருக்கேன். Now I'm going for the fourth one. Yes, Suchita. Okay, so fourth resistor I'm going to consider. Okay, fourth resistor பார்க்கும்போது one side is V1, another one is V2. So this is what V1, this is what V2. இது வரைக்கும் clear ஆடா? Can you please let me know with a black heart now this time? Apart from black எல்லாமே வந்து புரியல. Okay, இந்த வாட்டி black னா you know it, you understood. Yes, Angel. Oh my god, எப்படி இருக்கேன்டா? Okay, so நம்ம fourth பார்க்கும்போது one side வந்து V1 தான், another side வந்து V2 தான். இப்போ வந்து நம்ம last fifth resistor தான் I'm going to take. Now you guys have to tell me fifth resistor ஓட one sideல V2 தான், another sideல VB தான். Okay, yes, நான் வந்து நல்லா இருக்கேன். Okay, clear. So now we are going to analyze in the 5 resistors வந்து நான் கொஞ்சம் analyze பண்ண போறோம். Analyze பண்ணிட்டேனா, which means இப்போ வந்து பார்க்கும்போது நம்ம in the second resistor, third resistor, fourth resistor, what you observed in the 3 resistorல காமனா நீங்க வந்து என்ன observe பண்ணிருக்கீங்க? What is the potential difference across this 3 resistors? Same. Very good Abhinaya. Correct இல்ல? இந்த 3 resistors பார்க்கும்போது இதோட potential difference வந்து across these resistors வந்து same தான். அப்படினா can I say that இந்த 3 resistors வந்து parallel தான்? ஏனா வந்து parallel, இப்போ வந்து நம்ம circuit வந்து parallelனா மட்டும்தானா we used to say same potential difference. அப்படினா இந்த 3 resistors வந்து can I say that they are in parallel? Yes or no? Which means which are the resistors? Second one, third one and the fourth one are in parallel. Okay, so right now I'm going to mark these 3 resistors. Okay, I'm going to mark these 3 resistors. So let me say இதுதான் வந்து நம்ம V2 potential, Okay, V1 potential and இதுதான் வந்து நம்ம V2 potential. This is our first resistor, second resistor, third resistor. இது வரைக்கும் clear ஆடா? Can you respond with the pinky heart, pinky heart, pinky heart, everybody? Everybody, இது வரைக்கும் clear na? Okay, இப்போ வந்து இந்த question solve பண்ணும்போது you will feel like, oh ma'am, this is time consuming. ஆனா இது வந்து ஒரு வாட்டி click I mean, if you're feeling like it's understood, அப்படின்னா each and every problems வந்து easy தான் போக போறோம். Okay, clear? Voice is breaking ah. Ama? Yes or no? Can you please let me know? Audio வந்து perfect ஆடா? Okay, perfect. So this is what is happening. Innum two more resistors irukku. Okay, so tell me in the first resistor oda potential across ennada? One is V1. So one end வந்து எனக்கு வந்து இதுல இருந்து start பண்ணலாம். And this is what VA. Correct. So I'm getting this. அப்படியே I'm going for the fifth one. Fifth one illa one end வந்து V2 தான். Okay, another one வந்து VB தான். So இப்போ வந்து எனக்கு circuit கிடைச்சிருக்கு. Okay, இப்போ வந்து circuit கிடைச்சிருக்கு and ஒவ்வொரு ரெசிஸ்டர்ஸுமே all are equal resistors. So இப்போ வந்து equivalent resistance find பண்ணும்போது what I will be getting, this is our first resistor 1. இது வந்து இந்த 3 ரெசிஸ்டரோட equivalent resistance தான். What is that value? What is that value? So இது வந்து 1/3 தான். And again we will be having one more resistor, that is 1. So this is again potential A and this is what? Potential B. So right now 3 resistors are in series, which means you can just simply add these 3 resistors. 1 plus 1/3, which means 2 plus 1/3, which means 7/3 will be the answer. Hence I can say that option B will be the right answer. Clear? Everybody understood? Okay, angel simple தான் இருக்குடா. நம்ம வந்து V1 இருக்கிற பாயிண்ட்ல இருந்து there is a line going, right? Okay, we are just connecting the same potential to this point. அப்படியே I have just இது வந்து இன்னும் டிஃபரெண்ட் ஆன வேல்யூ தான் ஆக போறோம். So I'm just randomly giving V2. Okay, it is not necessary that you should give V1, V2. Anything you can go for it. Clear ada? Everybody, can you please let me know with your favorite heart? Everybody please respond with your favorite heart. Quick. So அப்படினா இன்னொரு question பண்ண போறோம். Okay, இன்னொரு question பண்ண போறோம். So you can just do this question and you can just let me know the answer. I will just come in 2 minutes, okay? Okay, just do it. I will come in 2 minutes. So yes, I hope you guys got the answer. Everybody got the answer? Very good, very good, very good, very good, very good, very good. So let us see. இப்போ வந்து பார்க்கும்போது தெரியும் இந்த two resistors ஓட okay இந்த two resistors across இருக்கிற potential வந்து same தான் correct இல்ல so now I can say that இந்த 2 ohms வந்து actually parallel தான் அப்படினா சொல்லுடா அப்படினா சொல்லு இதோட equivalent resistance என்ன இந்த 2 ohms ஓட equivalent resistance என்ன tell me guys tell me everybody. Yes, Pratap was super confident. Yes, it will come as 1. அப்படினா நான் வந்து இந்த diagram வந்து redraw பண்ண போறோம். Again, I have a triangle. This is what 1 ohm. This is what 5 ohm. And this is coming as 6 ohm. And we need to find the potential across this. We need to find the equivalent resistance across these 2 points. அப்படினா, what about 1 and 5? இப்போ வந்து 1 ஓட 1 endல இருந்து நான் வந்து start பண்ணிருக்கேன். So without any problem, I could reach. There is no junction till இது வரைக்கும். அப்படினா 1 and 5 வந்து சீரீஸ்ல தான். So now again I'm going for the equivalent circuit. So this is what our 6 ohm and the 5 and 1 ohm வந்து again சீரீஸ்ல தான் இருக்கு. So 6 ohm it will come. So we can say that 6 ohm I can say that parallel da, so it will be coming as 3 ohm as the what equivalent resistance. So now I can say that option C will be the right answer. Clear arigada everybody? Everybody please let me know. Six and 5 எப்படிடா series வரும் வரும்னா நான் என்ன சொல்லியிருக்கேன் we need to draw without any இப்போ வந்து நான் இந்த 6 ohm ஓட 1 cornerல இருந்து ஸ்டார்ட் பண்ணிட்டேன் ஓகே ஆனா வந்து இங்க வந்து ரீச் ஆகும்போது என்னாச்சு இங்க வந்து ஒரு பாயிண்ட் இது வந்து பொட்டன்ஷியல் பாயிண்ட் தான் இது வந்து ஒரு ஜங்ஷன் தான் அப்படினா எனக்கு வந்து சொல்ல சாரி இது வந்து அந்த ஜங்ஷன் இருக்குதுனால I cannot say that இது வந்து சீரீஸ்ல இருக்கு okay clear இருக்கா clear and guys don't forget to like the session quick like பண்ணுடா okay so we can just do the another question over here okay இந்த question பண்ணலாம் So now you can just do this and tell me what is going to be the answer for this particular question. So now வந்து நேத்து சொல்லியிருக்கேல just understand just mark the potentials at each and every points அதுக்கப்புறம் ஒவ்வொரு each and every resistors உங்களுக்கு choose பண்ணலாம் அப்படியே you can do it. Take your time and let us do it together. No worries. உங்களுக்கு வந்து இப்போ வந்து if you can't do it நாலும் பரவாயில்லடா we will do it together. Done, Nada. Okay. So right now, again the same method da panna porom. Okay. So இது வந்து ஒரு common junction. இதோட potential வந்து I'm just making it as V. Okay. அப்படின்னா இந்த 4 resistorோட 1 endல இருக்கிற potentialோட value என்ன? V தானா? And it is given in the question, whichever be the resistors touched on this line. இதுக்கு வந்து என்ன? Potential வந்து VB தான். Okay. அதோட potential வந்து same தான். Okay, right now I'm going to give the names for all the resistors 1, 2, 3, 4 and this one is coming as 5. Hey, what I have done. Okay, so right now this is what the V, this is what the first resistor, second one, third one and the fourth one. Clear arka? Idu varaikkum clear ada? Can you please let me know? Throw your favorite heart please. Everybody tell me. So அப்படினா first question, நம்ம first resistor ஓட across இருக்கிற potential என்ன? First resistor ஓட across இருக்கிற potential. So this is what VA and this is other end வந்து common potential லதா. So this will be coming as V. Okay. So right now I'm going for the second resistor. Second resistor ஓட across what is the potential? Tell me. Second resistor order, one is V, another one is touched on the outer, that ring. Correct. So now we can say that it is V and VB. Now going for the third one. Can you please let me know? Third one சொல்லும்போது one is V, another one is VB. So V and VB. Next one, fourth, the last one. Tell me da. Ghost. என்னடா கோஸ்ட் எல்லாம் வருது சடனா என்னாச்சு? Okay, so right now what is the potential? One is V, another one is VB. Correct alla? So now this is the thing. Now you have to tell me which are the resistors are in parallel. Which are the resistors are in parallel? Tell me quickly. You can just give me the numbers of the resistors. Which one is coming as parallel? You can tell me now. So wherever you can see the same potential, you can say that that is in parallel. அப்படினா I could say that in the 2 to 4 வந்து parallel தான் இருக்கு. So now I'm going to mark that. Okay, so the 3 resistors with the same potential difference. So one end will be V, this will be V and this is going to be VB. ஆனா வந்து இந்த V ல இருந்து இன்னொரு resistor இருக்கு. Okay, இந்த V ல இருந்து இன்னொரு resistor இருக்கு. And that is how it comes. Clear ada everybody, and all the resistors is having the resistance R. இது வரைக்கும் clear னா கொஞ்சம் சொல்ல முடியுமாடா with your favorite heart please? Quick. Okay, so இப்போ வந்து நான் என்ன பண்ணிருக்கேன், same potential difference across இருக்கிற resistors எல்லாமே வந்து parallel connect பண்ணிருக்கேன். And one more resistor இருக்கு, அந்த resistorோட one end வந்து இந்த ஒரு terminalல தான் இருக்கு. So I'm just connecting with that. So அப்படியே சொல்லும்போது இது வந்து என்ன R by 3 இல்ல. So I'll be getting the equivalent circuit like this, R by 3 and R. So இது வந்து 2 resistors வந்து seriesல தான். So now you can just do R by 3 plus R. So what you will be getting? 4R by 3. Hence I can say that which is the right option? Which is the right option da? We will be getting option B as the right answer for this question. உங்களுக்கு clear ஆச்சுனா you should give me a white heart right now itself. Quick. Yes. C. Yes, B. Perfect. என்னடா நீங்க வந்து you are talking about ghost. எனக்கு தெரியல என்ன அபிநயா? White heart ஆனதுனால? Why you are saying ghost? Okay. So now we are going for the next topic of this chapter, which is nothing but cell, EMF, terminal voltage and everything. Okay. So right now, let us say what is a cell? You guys have to tell me what is a cell. அது நீங்க தான் வந்து சொல்லணும். What is a cell? Cell வந்து of course a device, ma'am. Okay. So cell வந்து ஒரு device தான். அந்த device ஓட purpose என்ன? Device ஓட purpose என்ன? It is very simple. Convert the chemical energy to the electrical energy. Okay? So இப்போ வந்து cell represent பண்ணும்போது usually we will be represent like this. ஆனா வந்து now I'm going to give a modification. Okay? So cell represent பண்ணும்னா you have to represent like this. Why? Why? ஏன்னா வந்து we know that external resistance clear-ஆ நமக்கு தெரியும். Okay? External resistance வந்து clear-ஆ நமக்கு தெரியும். Unit of life அபிநயா. Okay? So animal cell, plant cell எல்லாமே இருக்குடா. Okay? நான் வந்து I'm switching this to biology class. Then சொல்லு what is exactly a cell? How you will define a cell? Yes, Angel, it's internal resistance. So basically சொல்லும்போது இப்போ வந்து ஒரு cell வந்து if you're connecting with a bulb இல்லைன்னா ஏதாச்சும் ஒரு device, anything you are just connecting னா அந்த device ஓட இல்லைன்னா அந்த bulb ஓட resistance தான் external resistance சொல்லும். But actually speaking, நம்ம இந்த செல்லுக்குள்ள it is electrolytes are there, it is having some anodes and cathodes are there, which means basically electrodes are there. So இந்த செல்லுக்குள்ள என்ன இருக்கு? Electrodes இருக்கு as well as electrolytes இருக்கு. So when the electrons are traveling from one point to another point inside the cell, it will give some kind of resistance. Clear arka? It will give some sort of resistance. Okay? So and the resistance provided by the cell itself is called the internal resistance. Clear arikada? Can you please give me a white chart if you understood what is internal resistance? Internal resistance na enna? It is provided by the resistance provided by the electrodes, electrolytes inside the cell. Clear ah? Adu vandu usually we will represent it as R. Okay? So idukapram we have two terms. Electromagnetic force and இன்னொரு term என்னன்னா yes, terminal voltage. Okay, both the values, both are voltages only. அதுல வந்து there is no difference. Okay, நீங்க வந்து EMF சொல்லினாலும் நீங்க வந்து terminal voltage சொல்லிட்டாலும் இது வந்து same voltage தான். ஆனா வந்து different name if you are giving new names. Okay, இல்லைன்னா different ஆன names if you are giving னா அதுக்கு வந்து definitely கொஞ்சம் difference இருக்கும்ல. Okay, so அந்த difference தான் நான் சொல்ல போறேன். Let us say நம்ம cell வந்து not connected with anything, which means அது வந்து என்ன open circuit. Okay, இப்போ வந்து நம்ம cell which stateல இருக்குடா? Which stateல இருக்கு? நம்ம cell வந்து actually சொல்லும்போது it is actually open தான். It is not connected with anything. அப்படின்னா current flow won't be there. Correct இல்ல? Current flow won't be there. அப்படின்னா அந்த டைம்ல நான் வந்து அந்த cell across நான் வந்து potential check பண்ண போறோம். Okay, I'm going to check the potential. Hey Steve, என்னடா இங்க? Go and study. இன்னைக்கு class இருக்குல்ல? 8:30 no, you have class no. Why you are here, Steve? Okay. So yeah. So right now நம்ம வந்து என்ன டிஸ்கஸ் பண்ணிட்டு இருக்கே? We were discussing about EMF. Okay, இப்போ வந்து நம்ம current is not flowing through the circuit. இல்லனா current is not flowing through the cell னா அந்த செல்லுக்கு across நான் வந்து ஒரு voltmeter set பண்ணி if I'm just checking the voltage எனக்கு வந்து என்ன கிடைக்கும்டா? என்ன கிடைக்கும்? I will get EMF. Clear ah? Okay. இப்படி நீங்க வந்து if you are coming here and going na exam time it is going to be very difficult da. Go bye. Okay, so right now என்னாச்சு? நான் வந்து இந்த cell வந்து I am connecting with the external resistance இல்லனா I am just connecting with the bulb or something. Okay, something I am connecting. அந்த டைம்ல okay, when I am just connecting with something different, hey என்னடா பிரதீப் சேம் பொட்டன்ஷியலா இருந்துருச்சுனா okay, let us say நம்ம previous questionsல எல்லாமே வந்து both the sidesல v1 கிடைச்சிருக்கு. Then whatever you said is correct. One pointல v1, another one pointல v2. Okay, another resistor v1 v2. அப்படினா அது வந்து short circuit இல்லடா, same potential இருக்கணும். இப்போ வந்து v1 and v2 வந்து same னா you can say that அது வந்து short circuit. Okay, clear ah? அது வந்து different ஆன batch டா. Okay, so now coming back to this, we have internal resistance, we have EMF and we have terminal voltage. இப்போ வந்து cell is not connected with any circuit. Okay, which means open circuit na இங்க வந்து what is the thing here? I will be equal to 0. அந்த டைம்ல நான் வந்து இந்த cell across I'm just keeping a voltmeter and checking it. So I'll be getting that potential as the EMF. Clear? ஆனா வந்து right now என்னாச்சு, நான் வந்து இந்த cell வந்து I'm connecting with an external circuit. Okay, இது வந்து capital R, இது வந்து small r. Okay, இப்போ வந்து என்ன, இங்க வந்து current இருக்கு. Okay, current is flowing. So right now நான் வந்து if I'm just checking the what is a potential using a potentiometer, sorry, voltmeter, what will happen, எனக்கு என்ன கிடைக்கும்டா, எனக்கு வந்து கிடைக்கிறது தான் terminal voltage. Clear-ஆ இருக்கா? Terminal voltage. So let us say I'm just going to discuss about charging and discharging. Clear? Charging, discharging time la definitely நம்ம cell ல இருந்து தான் charges should flow. Okay வா? Okay, cell ல இருந்து தான் charges should flow. அப்படினா என்ன ஆகும்? இப்போ வந்து cell ல இருந்து charges should flowனா நம்ம EMF விட நம்ம terminal voltage வந்து less ஆ இருந்தா மட்டும் தான possible-ஆ இருக்கும். Correct இல்ல? இப்போ வந்து discharging timeல E தான் வந்து பெருசா இருக்கணும். And in the EMF is utilized for two purposes. What are the two purposes? One is actually there will be a potential drop across the internal resistance. Another one is there is a potential drop across the external resistance. So the total EMF is splitted into two ways. Okay, நான் வந்து 10 apple I'm giving. In the 10 apple வந்து you have to eat. Okay, maybe 5 you will be giving your friend. ஏன்னா வந்து உங்க friend வந்து என் கிளாஸ்ல இருக்கு. ஓகே, சோ இப்போ வந்து என் கிளாஸ்ல எவ்வளவு நம்பர் ஆஃப் ஸ்டூடெண்ட்ஸ் இருக்கு, அவங்க வந்து என்ன பண்ணணும், வாட் எவர் ஐ எம் கிவிங் நீங்க வந்து ஃபினிஷ் பண்ணணும். ஓகே, அதுதான் வந்து நம்ம வாட் இஸ் எ ரூல். ஓகே, சோ இப்போ வந்து if I'm giving you EMF E, each of the component should be utilized by the rest of the, each of the component should utilize it. அப்படினா ஒவ்வொரு கம்போனன்ட்டுமே it will take it as a voltage drop. So அப்படினா எனக்கு வந்து என்ன கிடைக்கும், E I will be get it as IR plus IR I will get. Okay, so in the IR na enna, this is what the terminal voltage. So I can say that IR plus V it will come. Now this is for charging. Okay, this is for என்னடா, charging. இப்போ வந்து discharging caseல which value should be greater, E ஆ இல்ல V ஆ? Discharging இல்ல E ஆ இல்ல V ஆ? Which one should be larger? Definitely we can say that V should be large. ஏன்னா வந்து you are charging the battery. அப்படினா let us say இப்போ வந்து இந்த பேட்டரியோட voltage வந்து ஹையா இருக்கு அப்படினா charge won't flow, right? Correct. அது வந்து higher potential இருந்து தான் மட்டும் தான் it will come. So அப்படினா V should be high and the equation will be coming like this. Okay, V will be equal to E plus IR. So this is what the another thing that we should study. Now நம்ம வந்து resistors we have studied நோடா, அந்த மாதிரி we have to study for the combination of cell as well. Okay, clear-ஆ everybody? 20 minutesல எனக்கு தெரியாதுடா. ஓகே, இன்னொரு 10 minutesல நான் வந்து I will give a small break. அதுக்கப்புறம் we can just continue with the rest of the topic. Okay, இந்த combination வந்து we can finish. அதுக்கப்புறம் ஸ்லைட்டா ஒரு 5 minutes break. ஏன்னா வந்து நான் வந்து எனர்ஜி வந்து it is reducing. Okay, so அதுக்கப்புறம் we can just continue with the rest of the part. அதுக்கப்புறம் ஒரு 30 minutesல finish பண்ணலாம், பரவாயில்ல. Clear? Okay, done. So now we are going for the combination of cells. Combination of cells. Let us say நீங்க வந்து you are just connecting the cells like this in series pattern. Okay, in series pattern la நீங்க வந்து if you are just connecting na there is no confusion. அவ்ளோ சிம்பிளா இருக்கு. So equivalent EMF will be just added E1 plus E2 plus E3 and resistance, internal resistance ஆ இருக்கட்டும், external resistance ஆ இருக்கட்டும், whatever it may be, it will be in the same format. What will be the R equivalent? Can you please let me know? It will be R1 plus R2 plus R3. Clear ada? Okay, மறக்காம everyone should like the session and also subscribe the channel. So this is what the thing. Correctா? இப்போ வந்து let us say எனக்கு வந்து இன்னொரு cell இருக்கு. So what is the thing here? What you have observed here? இது வந்து opposite directionல தானே இருக்கு. Okay, இது எல்லாமே வந்து இப்படி தான் இருக்கு. ஆனா வந்து it is actually உல்டா தான். அப்படினா what I will do? I will go for minus E4. And resistors la change எதுவும் இல்ல. Resistors whether the cell is like this or this, resistors will be added up all the time. Clear இருக்கா? Everybody, cell in series mode la இப்படி தான் வரும். Okay, and if you wanted to find the current, what you should do? what you should do, the current in the series connection will be coming as the equivalent EMF divided by the external resistance into, plus the internal resistance or equivalence. Okay, you can just note it down. Now we are going for the parallel combination. We are going for the parallel combination. Ready? Ready now? Put some fire. Quick. Put some fire if you're ready for the parallel combination. Perfect. So, appadina we are going for the parallel connection. Okay, parallel connection சொல்லும்போது இப்படி தான் இருக்கும். Okay, so this is what one cell, this is what the another cell. This is how the circuit. This is what E1, this is what R1, this is what E2, and this is what R2. So, இப்போ வந்து இந்த circuitல if you wanted to find the E equivalent na, the equation will be like this: E1 by R1 plus E2 by R2. If there are more terms, you can just go with that, divided by 1 by R1 plus 1 by R2 plus etc. etc. Again, how will be we will be finding R equivalent? It will be 1 by R equivalent, which is equal to 1 by R1 plus 1 by R2 plus etc. etc. Correct. Now let us say if you have only two cells, okay, you have only two cells. Appadina in the E equivalent will be coming as E1 R2 plus E2 R1 divided by R1 plus R2 it will come. And we know already R equivalent will be R1 R2 divided by R1 plus R2. இது வந்து எப்போடா? இது வந்து எப்போ? When it is connected with we have only two cells. If we have only two cells, this is the equation we will use. Clear arkada? Everybody, can you please let me know? Can you please let me know? So, இப்போ வந்து next வந்து we have Kirchhoff law, Wheatstone bridge, as well as we have the power as well. So, அது வந்து இன்னொரு small break க்கு அப்புறம் we can just start da. Okay. So right now you can just complete the notes, and we are just going for a very small break. Okay. We can just come back by 8:55. So see you guys. Let me just take a very quick. Angel da moving charges will be in the next week only da, this week illa. Okay. Yeah. Hello, everybody. Audible ஆடா? Yes, perfect. So let us continue. So we were just discussing about the cell order combinations தான் நம்ம வந்து discuss பண்ணியிருக்கேன். Now we are going for the what? We are going for the next topic which is nothing but Kirchhoff law. So Kirchhoff law la first law என்னடா? It is actually the junction rule தான். Correct இல்ல? Can you please let me know what is junction rule? What is junction rule? The current entering into the junction which is equal to the current leaving the junction. Correct ada? Current entering into the junction which is equal to current leaving the junction. Correct? Can you please let me know? Yes or no? Appadina, what is going to be the sum of the current at the junction? What is the sum of the current at the junction? So it will be coming as 0. Yena vanda current, if you are just checking on the current which is entering and leaving is 0, same. So appadina and the point la irukra current vanda it is going to be 0 da. Next one enna voltage loop rule da. Okay, so in the loop rule na enna, let us say we have a circuit like this. Okay, let us say we have a circuit like this. Okay, so இதுதான் வந்து நம்ம circuit. So now in the case ல சிம்பிளா சொல்லிட்டேன், இது வந்து loop 1 தான், இது வந்து இன்னொரு loop 2 தான். So now if I'm just finding the sum of the potential difference along the closed loop, it should come as 0. Which means நான் வந்து நேத்து சொல்லியிருக்கேன்ல, என் கிளாஸ்ல இவ்வளோ number of students இருக்கு. Let us say 10 students இருக்கு. அந்த 10 studentsக்கு I have given some 10 apples. Okay, நீங்க வந்து ஈக்குவலா இல்ல ஷேரிங்கா whatever you do I don't know, but 10 apples நான் வந்து I have given னா நீங்க வந்து அதை finish பண்ணணும். So that is what the ideology. இங்க வந்து ஒரு செல் இருக்கு, இதோட EMF let us say E தான். Okay, so அப்படினா இந்த EMF if I'm giving na இந்த closed loop ல இருக்கிற components னா என்ன? We have the 3 resistors in the first loop இல்ல, அந்த 3 resistors should utilize this E. Okay, which means the voltage drop across this should be equal to the EMF we are providing. Exactly the similar way we can say here as well. Whatever be the EMF we are giving over here, it has to be utilized by the components in the circuit. Okay, so அப்படினா what will happen? EMF na வந்து I have given and நீங்க வந்து utilize பண்ணிருக்கீங்க. What is the net? What is the difference in EMF? இல்லனா potential difference என்ன right now? It will be coming as 0. Clear ஆ இருக்காடா? Everybody கொஞ்சம் சொல்லுடா please. Everybody please let me know. Yes, இப்போ வந்து இந்த question பண்ணலாம். Okay, you can do the question and please let me know. What will be the answer for this particular question? கொஞ்சம் செக் பண்ணுடா. இது வந்து ஜங்ஷன் ரூல் தான் நம்ம வந்து யூஸ் பண்ணியிருக்கேன். Okay, let us do it. So, இப்போ வந்து என்ன இந்த ஜங்ஷன்ல, okay, I'm just marking this junction. இந்த ஜங்ஷன்ல 15 ampere is coming and 8 ampere is coming. So, அப்படினா what is the current leaving? What is the current leaving from this junction? இப்போ வந்து junction A. This is what junction A. அங்க வந்து 15 plus 8 ampere current is entering. அப்படினா leaving எவ்வளவு இருக்கும்? It is going to be 23 ampere. So now நீங்க வந்து பார்க்கும்போது 23 is coming here, 3 is coming here and something is leaving. அப்படினா what is the amount of current? What is the amount of current? Very good, Hali. Very good, very good. So, இப்போ வந்து 23 and 3 na current entering should be equal to leaving. So, it will become 26. Correct? So, this is what our junction B. Now, coming to junction C. Junction C la 26 is entering. I and some other value. எனக்கு தெரியல. So, I'm just writing. At the junction C, what is happening? 26 is entering. And leaving is x plus I. எனக்கு தெரியல இந்த x என்ன I என்ன எனக்கு தெரியல. I தான் actually எனக்கு find பண்ணணும். So this is what the junction junction D. அப்படினா கொஞ்சம் equation சொல்ல முடியுமாடா? What is the current entering and what is the current leaving? கொஞ்சம் சொல்ல முடியுமா? Everybody at junction D ல junction D ல what will be the current entering? Entering is actually x தான். Current leaving will be 2 plus 8 da. So which means it will be coming as 10 ampere. So x I got it as 10 ampere. Now this problem is sorted. Okay. So yena வந்து 26 ampere which is equal to x oda value வந்து 10 da plus I da. Which means I will be coming as 16 ampere. Hence which is going to be the right answer da? Which is going to be the right answer? We will be getting option C as the right answer. No one has told me option C is the right answer. Okay. So now I hope it is clear. Yes or no? Konjam solla mudiyumada with your favorite heart? With your favorite heart konjam solla mudiyuma? Everybody? Yes, very good. Paravalada, mistakes are okay. Ana வந்து அதுல இருந்து you have to study அவ்வளோதான். Okay. Concept clear ஆ இருக்கா? Tell me everybody. Tell me everybody. Yes. அப்படினா can we do one more question? Ready ஆ நீங்க? If everybody is ready, we can go for the next question. என்னடா sorry இல்ல. Don't say sorry and all. Questionல answer வந்து wrong ஆச்சு. அதுக்கு இப்போ என்ன? Okay. So இது வந்து அவ்வளோ ஈஸியான ஒரு question தான். Okay. சிம்பிளா இருக்கிற கொஞ்சம் calculations மட்டும் தான் இருந்துருச்சு. அதுதான் வந்து நான் வந்து சொல்லியிருக்கேன். Okay. So now we are going for the next question. I hope everyone will give me the right answer for that particular question. So you can just do the question and let us see. Yes. Correct answers. Very good. Okay, so let us do this question. இப்போ வந்து பார்க்கும்போது we have I1 over here, I3 is flowing here, so I2 is flowing over here. So we just wanted to create an equation. கரெக்டா? So இதுல வந்து I2, I3 இருக்கிற ஒரு loop தான். So which means நம்ம first loop தான். Okay, so இதுல வந்து என்னன்னா, let us say if you are just considering, okay, E2 எங்கடா? Okay, E2, okay, this one da. We should consider this one. இதல்ல. ஏனா வந்து நம்ம equationல இருக்கிறது என்ன? We have R2, we have E2, we have E3, R1, everything is there. So we have to consider this loop. Clear ah? So இதுல வந்து என்ன பண்ணும்னா, I am going to do one thing. Let us say I'm just going to consider the anti-clockwise direction. Okay, so இப்போ வந்து இந்த லூப்புக்கு நான் வந்து I am assigning a direction. You can use clockwise, you can use anti-clockwise, no issues at all. Okay, இதுல வந்து whenever, let us say இதுல வந்து நம்ம anti-clockwise if you are taking na, இது வந்து நமக்கு I mean according to me the flow of current வந்து இந்த directionல தானா, lower potential to higher potential இல்ல. Okay, anti-clockwise சொல்லும்போது என் direction வந்து lower to higher தான். அப்படினா I can just write it as plus E2. Okay, coming to this R2. Okay, ஏன் direction வந்து இப்படி தான் இருக்கு, கரண்டோட direction மார்க் பண்ணியிருக்கிறது வந்து exactly opposite directionல தான். அப்படினா opposite direction வந்தேனா எனக்கு வந்து I can just again make it as positive. So which means அங்க இருக்கிற potential drop என்ன, I2 R2. Clear ஆ இருக்கா? Next one this. So இதுல வந்து என்னாச்சு, நான் choose பண்ணியிருக்கிற direction and I3 ஓட direction வந்து same தான். Direction வந்து same னா நீங்க வந்து என்ன பண்ணணும், you have to take a negative sign. So this will become I3 R1 minus. அதுக்கப்புறம் இந்த E3 consider பண்ணும்போது higher to, நான் வந்து anti-clockwise இல்ல, anti-clockwise பண்ணும்போது actually வந்து higher to lower potential தான். So அப்படினா இது வந்து minus E3 which is equal to 0. ஏனா வந்து sum of the potential difference in a loop will be 0 தான். So அப்படினா இதுல வந்து which one is matching with it? Which one is matching? Definitely நம்ம option B தான் matching with it. So I can say that option B will be the right answer. Clear ஆ இருக்காடா? Everybody, please let me know. Please quick ஆ சொல்லுடா. Yes. அப்படினா we are going for the last topic of this chapter, that is nothing but energy and power. So basically we know that power and energy ஓட relation என்னடா, power which is equal to energy by time தான். So அப்படினா எனக்கு வந்து power ஓட equation கிடைச்சேனா I can just multiply it with T, then I will be getting energy. அப்படினா நம்ம energy ஓட equation சொல்லும்போது I can go for I square RT, I can go for V square by RT. Also, I can go for VI into T. So, இப்போ வந்து power என்ன? I square R. Then I can go for V square by R. Also, I can go for VI. So, these are the equations. இந்த power ஓட equation use பண்ணி நிறைய questions இருக்கும். Let us say, இப்போ வந்து if you are just connecting in a series format லனா definitely அங்க வந்து பார்க்கும்போது சீரீஸ்லனா I தான் வந்து கான்ஸ்டன்டா இருக்கும். அப்படினா நீங்க வந்து you have to choose this I square RT ஓட equation. ஏனா வந்து if you are just doing V னா அது வந்து கொஞ்சம் டிஃபிகல்ட்டா இருக்கும். ஒவ்வொரு ரெசிஸ்டருக்கு அக்ராஸ் இருக்கிற பொட்டன்ஷியல் வந்து டிஃபரெண்ட் தான். So you have to find it and you have to do it. அது வந்து இப்படி you will be touching. Okay, ஆனா வந்து let us say if you wanted to find it in a single stretch na, series connection I will be same. So I இருக்கிற equation choose பண்ணலாம். Okay, depending upon the data or whatever it is given, அதோட பேசிஸ்ல உங்களுக்கு வந்து பண்ணலாம். And இந்த பேஸ் பண்ணி நம்ம பவர் ரிலேட்டடா இன்னும் more questions இருக்கு. அந்த question session வந்து அப்புறம் பார்க்கலாம்டா. இன்னைக்கு வந்து it's almost என் எனர்ஜி கூட டெட்டா இருக்கு. Okay, almost நான் வந்து டெட்டா இருக்கேன். So guys, don't forget to like the session. Also subscribe the channel. Also share with your friends. And those who wanted to join the MVSAT scholarship, you can join. Link is in the description box. Okay, so now this is the thing, and we will be meet after some time. எனக்கு வந்து I wanted to know how was the class, how effective it was. எல்லாமே வந்து comment boxல தெரியணும்டா, மறக்காம அதோட feedback மறக்காம you have to put it in the comment box. ஏன்னா வந்து in futureல many students when they are coming to the channel and when they saw this video, அவங்களுக்கு வந்து confidence கிடைக்கிறது வந்து இந்த comments பார்த்து தான். So I mean, once you are done with the session and you are feeling like it was useful, அப்படின்னா மறக்காம I mean, you have to put the comment as well. So thank you so much, guys. Bye bye. Thank you, Lakshya. Thank you so much, da.